Uh, Good morning to dear participant, dignitaries, resource person. We will be starting in 2 minutes. We are waiting for a few members to join. Thank you.
Hello, Roja?
Yes, sir.
Yeah, am I audible?
Yes, sir. You're audible, sir.
Okay. So, shall we, so attendees are 172. So should we wait for some more time?
Yes, sir. Surinder, sir, from HCL Chandigarh.
I have actually spoken with him. So, he is joining by 10. Okay.
And so we are waiting for Ahuja ma'am to join. She was having some problem with the invite link, so she is joining in another 1 minute. And sir, Aprajita Ahuja ma'am.
Okay.
And sir, Sahula sir also, we are waiting for Sahula sir to join.
So I call him.
Yeah. Sir, Aprajita ma'am joined.
Okay, thank you.
Thank you, sir.
Good morning, Gaurav. Good morning,
Good morning,
everybody.
madam. Very good morning.
Sir, good morning, sir. Sir. Good morning, sir.
Just a moment. Can you please call Saula, sir? Please.
No, okay, sir. Sir, I will call, sir.
Yeah. I'm trying to reach him as well. Hello. I'm sorry for the little delayed start of the inaugural ceremony because Professor Vineet Sahula, we are waiting for him to join, and we are also waiting. So I think we start with that, and then we will start with the talk of Surinder.
सर विनीत सर का बात कर दिया सर. सर मॉर्निंग सर.
हम आपने नहीं किया, मुझे तो आप लगा रहा है.
Sir, he is not lifting, sir. Actually, that's why.
Oh, okay.
Okay.
I just.
Otherwise, sir, we can start, sir. I think he will join later.
Yeah, I think we'll start. I just call him. If he did not speak, then we start.
Okay, sir. Thank you, sir. Thank you.
Namaskar, sir. Hello. Morning, sir. Sir, we are waiting for you to join for the inauguration ceremony. Okay. अरे हाँ परीक्षण चल रहा है. I know. Yeah. I think we start the inaugural ceremony. Professor Vineet Sahula is fasting, so he will not be able to join. I begin the inaugural ceremony, and a very good morning to all of you. We are very much thankful for you to that all of you are present here for the inaugural ceremony, and I really welcome Mr. Hari Vasamma. He is Velasma. He is from Siemens Minter, and Minter Siemens from Finland, and one of the well-known 5G expert on the globe. I also welcome Professor Ratnesh Bhattacharjee, who is a principal investigator of E&ICT Academy. I welcome Dr. Bharat Gupta, who is a principal investigator of E&ICT Academy, NIT Patna. I welcome Professor Apraita Oja, principal investigator from IIT DM Jabalpur, and I also expert all the I was all the expert of this course, Dr. Aditya Dalakoti, Mr. Puneet Mittal, and Mr. Ashish Jindal. A very good morning to all of you. That we all are here. So here in this for this particular 5G course, when we were discussing about launching this course 5 months back in our during our meeting at MNITJ Jaipur, we know that a 5G is making a significant impact, and 5G has not yet adapted by the entire world yet, but the efforts are going on, and the transformation from 4G to 5G is going on. And in this particular transformation, people are still now they have started talking about the 6G or you can say the terahertz communication or many other you can say the super fast communication techniques also, and so it will take some time to come. But 5G is it's a currently you can say it's one of the best known you can say communication channel and medium. So we have specifically so we have decided to just put this course here with the emphasis that if I have to design a particular 5G system, then what kind of requirement would be there at the chip level to design, and so that part is specifically in having this particular you can say this particular problem in our mind. We have started this. We have laid down the course, and fortunately, we have got the our experts help like Dr. Aditya Dalakoti, Mr. Ashish Jindal, who are working in the area of 5G, and Mr. Puneet Mittal also, who is actually is an expert in working in the area of wireless since last 12 years. So we became very confident that we actually can deliver this course efficiently to the scientific community in the India. And thanks to Siemens Mentor for their cooperation, and once again, when I requested them that can we have a 5G expert to deliver a keynote address in this particular talk, then they very much agreed to this. So specifically in this, they have proposed with the name of Mr. Hari Rasman, who is a well-known 5G expert in this area, and we agreed to this. Fine, I'm to say, because what is the industry perspective in this 5G and where the industry lies and what are the actual challenges are there? That part also we need to know. So here, without taking much time further on my own, I request Professor Ratnesh Bhattacharya to say welcome words to the community. Thank you. Professor Ratnesh Bhattacharya.
Thank you, Gaurav, for inviting me. Can you hear me?
Yes,
Yes,
sir.
sir.
I can hear you. I can hear you.
Okay. So, distinguished panelists, my fellow CI and co-CIs of the E&ICT academies, and the esteemed participants of this program of demystifying 5G, and this being a FDP, we will have the participants, mostly they are faculty member in different institutes across the country. So I welcome you all to this faculty development program, and I am very thankful as a PI of the academy to my colleague Dr. Trivedi for taking this initiative and bringing a galaxy of experts from different laboratories, DRDO, ACL, Samir, and also from the industry, Siemens. And I could see a good mix of experts. In fact, a larger chunk of the experts are from the industry or the R&D labs. From academia, I think he has also invited me to talk for an hour, a communication person's perspective about these IC technologies, because ultimately this is targeted to be used by the communication fraternity. And my colleague, Dr. Mahima, she is also expert in this RF. So we have a good mix of R&D labs, academia, and industry people delivering this course. 5G, as we know, I will discuss in my lecture in detail. In India, we are still have not initiated in that way. The frequency bands which have been actually identified so far, it is in the sub 3 gigahertz band, sub 6 gigahertz band, 3.3 to 3.6 gigahertz. And discussion on releasing higher frequency bands, particularly in the millimeter wave, is still on. 5G also includes very low frequencies. As we know, IoT is going to be an integral part of 5G, and the technologies like LoRa and all, they operate at very low frequencies, around 600 to 700 megahertz. So the band over which 5G technologies will operate, this is huge, starting from sub gigahertz to sub 6 gigahertz to millimeter wave bands as high as the two bands 28 and 39 gigahertz. They are getting a lot of attention, and there is huge scope and enormous challenges in developing those technologies. And I hope this particular FDP is very, very well timed in that sense, because in India, we are just planning to get into the 5G activities and equipping our esteemed faculty members with what is happening around in the R&D labs, what is happening in the industry will actually give them an edge, and they will be able to transfer this knowledge in a more efficient way to their students who will be the future designers for this 5G and next generation wireless systems. So with these few words, I welcome once again you all, and I hope that this FDP will be a grand success. We have received a good number of registrations combining the 4 academies, which is roughly 750, and I hope this next few days will deliberate on various issues and it will be a very successful one. Thank you. Thank you all.
Uh, Thank you, sir, for your kind words. Now, may I request Professor Aparajita Oja to say a few words in this inaugural ceremony?
Thank you, Dr. Gaurav. And it is yet another important program in the series that you have been organizing on all cutting-edge technologies. And in spite of a very specialized course, I'm happy to see such a large number of registrations. And all credits to you and Professor Ratnajit Bhattacharya and his team. Uh, Thank you for accepting our request for adding our participants registered at IITDMJ. And I also thank Dr. Bharat and Professor Vineet Saula for their contribution in such an important program. All the panelist experts are from different industry and academia. It's a very good blend, as Professor Ratnajit Bhattacharya says, that it's a good blend of academia, industry, and R&D labs. So I'm sure the participants are going to uh, be benefited, and they will definitely pass on their knowledge and their skill set to the students. Thank you, Gaurav. That's all from my side.
Thank you, ma'am, for your kind words. May I request Professor Bharat Gupta to please say a few words to the audience?
Thank you, Dr. Gaurav Trivedi. First, very good morning to all the participants, all the CIs, principal coordinators, and the co-principal coordinator of this program, and as well as the academic level coordinator, proctor coordinators, and all the experts of this program. I welcome you for this Demystifying 5G RF ASIC, a 2-week long faculty development program, which is organized by IIT Guwahati, MNIT Jaipur, and the other 3 academies, NIT Patna and IITDM Jabalpur, are the participating. I really appreciate the efforts of Dr. Trivedi as well as the Dr. Periswamy to bring the pool of experts from every domain. Every domain means like from the academia, from the research, and as well as from the industry. And I hope that this program will be really benefited to the participants to make our India and to make the initiative of Atmanirbhar Bharat, because we are going towards in the 5G deployment. And as Professor Ratnajit Bhattacharya told that till now India is not nowhere as such, so we are planning to launch it. Naturally, the frequencies allotment for this 5G deployment will be there, and accordingly that how this RF ASICs will be designed and to make this 5G possible in India. And naturally, the next generation researcher and the next generation people will come up with new designings, and that will be utilized by all over India. And to make this program, I really appreciate the efforts of our academic level coordinator, Dr. Balchand Nagar and Dr. Manpuran Mehnat, Manpuran Mahato, that who has tried to bring out the around 250, but as in a whole total 750, but from NIT Patna side around 250 participants are there, and that's really, I appreciate the effort of both the academic level coordinators. And I really wish all the participants a great learning experience during this program, and have a very very good luck for the future learning. Thank you so much from my side. Thank you, sir.
Thank you, sir. Thank you, Professor Bharat, for this for your kind words. I am having now Sri Surinder Singh sir, who is the director of Semiconductor Lab Chandigarh, who he has just joined to this particular faculty development program, and so it's all there, and we are so now we are having Mr. Hari Valasma also here. So Dr. Hari's talk will be starting at 11, but I request him to say a few words in this inaugural ceremony. Mr. Hari, over to you, please.
Good morning from Finland, everybody. Thank you for inviting me for this event. Although it's very early in the morning right now in Finland, but anyway, looks sunny and nice. I'm hoping to give you some feedback on what we see in Siemens and Mentor about the 5G world, and hoping to hear more from you also how you see how things are going in 5G. 5G is really now the most important technology in the world, which will be affecting all the aspects of the world. And I know that India right now is very much leading there. There are many good things happening in India, and hoping to help you up in keeping up the good work. Thank you.
Welcome, Dr. Hari, for your nice words. I know that participants will really glad to know the industry perspective in the industry problems what industry is going through in the 5G area through your talk. Now I say Professor P.J. Swami to conclude this particular session by giving the vote of thanks so that we can start our talk. हेलो
पता है कैसे प्रेजेंटेशन कैसे शेयर करते हैं इसमें तो शेयर कंटेंट बीच में कुछ आता है
Sir, thank you, sir. Sir, thank you for your invitation, actually. So, first of all, I would like to welcome you, all of you, for this course, actually, Demystifying 5G RF ASICs, actually. And also, in the behalf of all academic, actually, once again, I welcome all the participants to this 10 days online FDP course, actually. And also I hope actually that all the participants actually they will get benefit from this course actually, because this particular course actually designed for a specific domain 5G actually, plus and all the experts from say ACL Chandigarh and the DRDO lab actually. So all are eminent expert from this particular domain. So definitely all the participants, they will get benefit from this course actually. So I would like to thank all that academy, including that IIT, particularly IIT Guwahati. They took all the efforts to run this to successful this course actually. And I also would like to thank to IIT partner and IIT Jabalpur for to join this particular course to make successful event. Okay,
Thank you, sir. Thank you so much. Okay.
Welcome, Professor Verisamy. Before I begin, I'm going to my the first keynote talk by Shri Surinder Singh sir. I just would like I just say that the three main experts actually in this entire course are Dr. Aditya Dala Koti, who did his bachelor's from IIT Ropar and PhD from US. We will be introducing him formally later. And Mr. Ashish Jindal, who also did his BTech from IIT Ropar, and he is currently working at SSPL New Delhi. SSPL is actually one of the part of DRDO labs, is one of the DRDO labs. And Mr. Puneet Mittal, who is alumnus of BITS Plani and having 12 years of work experience and in the area of military design. So they are the three main experts here in this, who will be carrying forward all the course. Since the session will start after lunch, so we will be introducing formally all three of the experts later. But I welcome them and I really thank them for their for agreeing for this course and from their busy schedule. And we wish that our association will be there in future very strongly. And now I invite Shri Surinder Singh sir to begin this particular faculty development program by delivering his keynote lecture. So here this is a basic, this is just an introduction of Surinder Singh sir. Shri Surinder Singh sir joined Space Application Center ISRO Ahmedabad in October 1986 after completing his Master of Technology in Microwave Electronics from University of Delhi. He was very actively associated with the design and development of space-borne hardware for satellite program right from the indigenous realization of IITG series. At present, as distinguished scientist and director, Semiconductor Laboratory SCL, he is leading the team for the development of standard IC blocks, application-specific ICs, charge-coupled devices, and detectors in 180 nanometer CMOS technology, and MEMS devices in 800 nanometer node. He was responsible for the RF subsystems in SATCOM and navigation payload area, and has been associated with many project responsibilities in different capacities. He was the Associate Project Director, Communication Payload, GSAT-8, and also led the team for Navigation Payload Development as Project Director, IRNSS Payload before his deputation to Semiconductor Lab, Chandigarh. His main focus has been toward development of high-performance, reliable, compact, and lightweight subsystems, and has been responsible for implementing many new state-of-the-art technologies in the satellite payload to achieve these goals. The system development, a system deployed by him for onboard application including low noise amplifiers, up and down converters, receivers, input multiplexers, multi-pass band filters, pre-selected filters, and analog IF match processor, a new technology element for efficient narrowband traffic management. Monolithic microwave integrated circuit of MMIC and dielectric resonator DR, high temperature superconducting field, RF micro electromechanical systems, and low temperature co-fired ceramic are some of the cutting edge technology used for development of these particular systems. He is recipient of many awards, including prestigious Platinum Jubilee Award 2009 for application-oriented innovation in physical science from National Academy of Science from India, ISRO Merit Award in 2009 for meritorious contribution to Indian space program, ISRO Team Excellence Award in 2007, 2010, and 2013, and ISRO Performance Excellence Award in 2016 in recognition of his excellent performance and contribution to its Indian space program. He has co-authored many national and international publications and is the principal investigator of US patent on dielectric resonator-based filters. He was member of Space Generation Task Group formed for long-term planning of ISRO space program and ISRO strategy group. Shri Surinder Singh sir is a member of IEEE and fellow of IITG and IICT. This is Shri Surinder Singh sir's brief profile. I request now Shri Surinder Singh sir to talk, to interact with the participants of the faculty development program and deliver his keynote talk in this. Sir, over to you. And we very welcome you for on this particular FDP. Although this is precisely the virtual one, so we cannot, since this is the virtual one, we cannot officially felicitate you. But this particular so this is a virtual. Please accept a virtual felicitation. And once again, I, on behalf of IITG Academy IIT Guwahati, and with my colleague Professor Periyaswamy from MNITJ Jaipur, we welcome you to deliver first keynote talk of faculty development program, demystifying demystifying 5G RF ASICs. Thank you. Thank you so much. Surinder sir is joining in a moment. He is having some issue. He is logged into different system, so he is just uploading his presentation. Just a moment. हाँ, हाँ. Surinder sir is login. Is just being present in a moment. In the meantime, we are having Shri Vijay Shetty sir here with us, who is actually working with Mentor Simmons India. So by the time Surinder sir join, may I request Mr. Shetty to please say few words about this particular course. Vijay sir. Mr. Vijay Shetty. I think he is.
I'm only first.
हेलो। ओह अच्छा, क्या बात है भैया, मतलब अच्छा तुम्हारा नया फोन है इसमें आ जाता है कौन कौन फोन के। अरे Yeah, please hold. Surinder sir is getting some problem to start this talk because he is behind firewall at HCL. In a couple of moments, he is joining again. Thank you.
Gaurav sir, we request you to please check.
Hello?
So
Are
now
you
it
able
is
to
visible,
Yes,
sir.
sir.
Sir, it is visible, sir. Now it is the PPT is visible.
Yeah, actually, I have to share from my side. And uh, okay, I think sir has left to join. So I will be, because there is he is behind firewall, so it is something like we are yeah. So I will have to help him. Actually, sorry, very sorry for the delay. There is some problem from Surinder Singh sir at his end. So actually, SCL is we did not anticipate that the entire organization is behind firewall. So there is some problem connecting to the outside virtual this video conferencing facility like the WebEx or so. So he shared the slides with me, but earlier he got connected, but again he got disconnected and some problem at his end. He's rectifying it. We just wait a moment more, and he just called me up saying he's joining me in a minute. So I'm really sorry for the delay, and thank you for your patience. Thank you. Yeah. Roja, can you please check whether sir has joined? Oh, Surinder Singh sir just joined. I think he just joined. Hello, Surinder sir, are you able to listen me? Yeah, I think he just came. Yeah. Firoja, are the slides visual?
Yes, sir. The slides are visible, sir.
Okay.
म्यूट ही है सेम आ रहा है ऐसा ही
Yeah,
अनम्यूट नहीं हो
sir, you are audible.
रहा हेलो
Yeah, sir, you are audible.
Okay, I don't know what is the. First thing. Let me apologize for all this. I think today perfectly the Murphy law, जो है, was applicable. First, my laptop went, on which I joined with you, but I don't know how it went off. And then all subsequently, wherever I was trying to join, the WebEx was not there, and I had to install this. Let me once again apologize for this. And let me thank Gaurav for giving me this opportunity to share with you whatever little work we are doing at SCL. Of course, my colleague will later on join you, and he'll also probably explain in detail the technologies. What I'll do now with this, whatever little time is left, is probably I'll very briefly try to tell about the semiconductor technologies and a little trade-off there. And very quickly, I'll try to go through the SCL, whatever activities are there I want to share with you. So as you can see, all of you have now experienced this. Electronics is there in everybody's life every day. Whether we are at ground doing any application or we are in space, as you can see from one of. So electronics plays a very major role. Okay, can you go to the next slide?
Yeah, sir.
So as you actually the electronics, once you see, it started all with the vacuum tubes somewhere early in 40s. Then it was 1947 when Shockley, Bardeen, and Brattain invented transistor, and that has changed the scenario, the scape for electronics. In subsequently, of course, Shockley also created a BJT, and then an IC was made with the two BJTs. But a big change, or I say big leap, happened when Fairchild introduced CMOS. And that was a big revolution took place. And as you can see the electronics after that has started getting integrated into all spheres of our life. Of course, genius Gordon Moore predicted at that time the trend see that the way the things were getting integrated, he predicted the trend for the chip density, that the density will be, the number of transistors will be doubling every 2 years. And the trend, of course, continued, and the scaling thing continued for a very long time. Of course, it is still going on, but it has slowed down a little bit. And now the people are trying for all kind of another wave of innovations and technologies to get the same kind of benefit which we could achieve through the scaling. We're going to go to the next slide. The next big revolution after I say the CMOS revolution is going to be the technologies which are needed for what is the today's topic also. And you will be going through this for now a couple of weeks through this all, that 5G. The 5G has led to I'll say in advent of many new technologies. Basically 5G, when you see, it is going to be the next big change, and that big change I see, though the electronics, as I said earlier, is in all sphere of lives, but now with 5G, the electronics will be, I'll say, will be almost embedded into our almost all daily applications. See, other than the speed and the low latency, what I see is what they mean to us is almost real-time applications. Wherever the applications are there requiring some real-time communication, those applications will be enabled by 5G. Another change will be, if you see, that will be machine-to-machine communication and device-to-device communication directly. So machine-to-machine communication will make the dream of fourth industrial revolution possible. And but at the same time, when if you see, then this is the kind of data you can see is going to be enormous. So how the 5G, can you go to the next slide? How the 5G is achieving this is basically through many, I'll say, many innovation. If you see behind 5G, such a big change from the current ongoing 4G is through many innovations in technologies as well as materials. Of course, these technologies involve all spectrum of, I'll say, gamuts. See, the 5G has led to innovations in multiplexing technologies, and then efficient spectrum uses of, and many techniques there, energy saving mechanisms, and then capex opex reduction technique. Like this is basically a software defined network now. So network virtualization concepts are there. But other than that, see, the big capacity, of course, it has refined all those things to get it. The other addition to this is the new spectrums. If you see the two main thing behind, if you see the kind of capacity and connectivity which will achieve is through a massive MIMO, beamforming networks, beamforming capability, and the new spectrum like introduction of milliwaves. So whether it is beamforming or it is the new milliwave spectrum, this has led to many I'll say new structures for the devices. See, semiconductor technology basically, as I said earlier, was moving around CMOS. Of course, for higher frequency and certain niche applications, people were using compound semiconductor, basically like gallium arsenide. And though gallium arsenide being slightly costly technology was mainly being used in the strategic arena. But with the 5G introduction of 5G, I think the GAN has also come somewhere around because of its real good capabilities. But I think 5G has given a big arm to GAN. And as you will see, that the first four here are CMOS, SiGe, LDMOS, and SOI, silicon on insulator technologies. So these technologies were there for some time. Of course, CMOS was the big leader, big dada. And wherever performance was needed, it was like in the low noise and small signal amplifiers over a very high frequency, SiGe was used. And for the power amplifier, the laterally diffused MOS or drain extended MOS was used. And SOI, of course, of late has started coming and has taken a good shape wherever actually the applications required very low power or particularly for RF when we had to go for higher frequencies. Gallium nitride, as I said, it is because of the upcoming applications like 5G and IoT. This earlier was being used only of late in the strategic again arena because of the prohibitive cost thing. But now people have innovated certain things, and this technology also is now competing with the existing technologies. Of course, as I said, that the new spectrum introduction in millimeter waves, the silicon technologies mainly were being pushed to corners. Of course, there are also many innovations have taken place, but naturally being a natural thing to the compound semiconductors, so GAN has also got a good place now for as far as the semiconductor technologies are there for 5G. Can you go to the next slide? Can you go to the next slide, Gaurav? So the best suited, no, just previous one first. Just previous one, yeah. So best suited technology require many consideration. It is not just one, I'll say. So as you can see at the bottom, one side doesn't fit all. So same is there for any new application or new problem. So one solution doesn't fit all for all the things. So basically the technology, when you have to choose, that require many considerations. Some of them primary consideration are a function, like what function we are supposed to take from the technology, whether switch, high power amplifier, low noise amplifier, converter, whatever. Then of course the frequency bands. Frequency bands, as I said, now introduction of millimeter wave again has now led to a new gamut of devices. Power level required, again compromises, and of course the other performances like noise figure linearity. Can you go to the next slide? You go to this. So basically the technologies are divided depending on, as I said, the performance and the function. So as I said in the beginning, that the main whatever performance achievement 5G is achieving is through beamforming, requiring phase array networks. So any phase array agent, like you have seen now in the whatever sub 6 gigahertz technologies are introduced, there is a minimum 4x4 MIMO or sometime higher MIMO is there. Okay, but when we go to the higher frequencies, of course, and some other applications, you require very massive MIMOs, and this beam for elements in the beamforming network are quite high. The number is quite high. The numbers are going as high as say, let us say 512, depending on again the number of element in each of this antenna element in the element chain depends on the technology which we use. Okay, so there are many performance parameters. So, but if you see the power wise, the power amplifier which dominates any chain in any such chain, so there this spectrum I have tried to put, and it's courtesy analog devices, that you can see the different technologies which are either existing or are upcoming. What is the frequency versus power, I'll say, comparison. So you can see the SiGe, silicon germanium, which is a very good technology. This can go to very high frequencies with the FT, but of course the power is not as high as we can get from the compound semiconductor. But what has been done by the system people is they have put more number of antenna elements. But see, if you will find that our system being configured with SiGe, that will have inherently more number of elements, so that the power gets divided among the power amplifiers, number of power amplifiers, so that SiGe fits in. Okay. But on the other side, if you see the GaN, so GaN, of course, the required number of elements, if the system is configured with GaN, they are less. But of course, the GaN has its own right now, mainly the problem related to the cost factor. See, GaN also, right now people are using GaN on silicon. I'll just come maybe in a later slide, probably if I have put that slide, I'll explain. So right now, because of the performance reason, people are using GaN on silicon carbide. Of course, silicon carbide is a niche, again, substrate available and costly substrate available. But people are again trying some innovation, going for GaN on silicon, so that we can come down in the cost, and that technology can be used widely. Of course, if you see here, silicon-based technology, the power amplifier LDMOS basically is used for power amplifiers. So there is a good competition between LDMOS and GaN. LDMOS, though the GaN is sweeping almost all arenas, but when we see the 5G, I think LDMOS is going to stay at least in sub 6 gigahertz bands, and it very well competes. The advantage of silicon technologies versus the compound semiconductor technology like GaN and GaAs is, other than the cost, the well-established facilities, the well-established foundries world over, and a good integration, which is available when we are seeing this in beamforming network, the phase array chains. See, normally you require a good amount of integration. So the silicon technology work very well there. So wherever the people will find the performance can be achieved with the silicon based technology, people certainly will prefer to leverage the existing infrastructure, and of course the cost benefit and integration benefits of silicon. Next, can you go, Gaurav? Gaurav, can you go to the next slide, please? Gaurav, can you go to the next slide, please? Gaurav?
Sir,
Can you go to the next slide, please?
Sir.
I knew this is not going to work very fine.
Sir,
Can you change it? No.
हेलो फिरोजा सर, आपको आवाज सुनाई पड़ रही है?
हाँ, मेरे को सुन रही है आवाज आपकी.
This is actually I was sharing. I was at the when you were there. I was just a moment. I'm having a lot of problems, Roja, with this WebEx today.
Okay, sir, can you please stop sharing and share it again? I think so it will.
Gaurav, can
Sir,
you try? Gaurav, can you try once? I can also try from here now sharing. Can you just stop?
yeah, Pabali,
Yeah, yes, ma'am. I'm giving the sharing rights to Surinder, sir.
thank you. Surendra, sir, the sharing right is with you, sir.
Okay, I'll just try that.
Yeah, okay, sure, sir.
Actually, today is this WebEx is working very funny. I have to say this is. I was trying to unmute and I was unable to get myself unmute. So I
Yeah,
don't know
this
what.
same problem almost is happening here also. Anyway,
Sir, are you able to successfully share it?
I'll just check that, and if I am Gaurav, can you see it?
No, sir. Nothing is here.
Oh, what is the
Sir, I do it in
problem?
my end only. Sir, I think there is some problem from your side in sharing. Again, we will go to that loop. So, sir, I share from my side. I think when you say to the next slide, I was on the next slide. I think it was not updating that fast. That was the only thing.
Okay, you can
So,
do then.
yeah, Pubali,
Yeah.
Do
immediately.
this. I think it is not. There is some problem.
Pabali, please give the
Yes, sir.
presenter
Yes, sir.
rights to
I have
Gaurav.
given the sharing rights, sir.
Yeah, I think.
Sir,
Thank
you
you,
are here.
Pabali.
I clicked on this slide.
Uh,
So you want this?
okay.
You are here. I had given the share. Where is the next slide? I reached here.
Yeah. Okay. Okay.
You want to skip
Uh,
this? We can skip this and we can go forward.
yeah. Yeah. You can the next slide. Basically, I have already spoken on that slide itself.
Yeah.
So,
This are
so basically, Gaurav, what I'll do is I'll not dwell too much. I have summarized on that slide itself whatever compromises are there. Of course,
okay.
there were many slides, and I wanted to talk about this technology a bit. But seeing now the time crunch, I think it is already 11.
Yeah.
So basically, the what I wanted to convey was, of course, maybe I'll take some time from you again,
Sure.
and maybe I'll try to go dwell a little more on this. Okay, all these technologies have something. Just stop here at CL. Maybe few slides I'll explain.
Yeah.
See, if you see the technologies, the silicon technologies are basically, again, I'll say tapered towards going for high frequencies and high power. Mainly the technologies which are going to be there in long stay are silicon germanium, LDMOS, of course, in sub 6 gigahertz band. Gallium nitride is going to take low noise functions also. Though gallium nitride is, because of its good power density and wide band gap, it is considered as a technology for power amplifiers, but very good low noise amps have been now made through gallium nitride. Of course, there are many innovations which are taking place again in gallium nitride field also. Maybe sometime other I will share with you. So the technologies to look for when we are looking in 5G, we should not, again I'll convey, look at just one side, because there are groups who are working fully towards SIGI. and there are groups who are working fully towards GAN, putting a GAN solution, totally GAN solution, and there are some groups which are towards totally SIGI solution. Of course, as you know, the 5G technology is being delivered by many carriers. So I think when we are choosing, and if we have a choice, so we should look at all the aspects, including the performance and the availability to us. That's all I wanted to say right now for this. I apologize for whatever this now today technology miss has happened. I'll very briefly for 5 minutes, Gaurav, if you permit, I want to show a little bit about some, because there's, you said there's a wide audience, and probably it is an opportunity for us to show a little bit.
Sure.
Is 5 minutes are permitted?
Yeah, sir, sure.
Okay, so quickly go through the next slide.
Yeah, sir.
It has not come.
Sir, it came at my end. Roja, are you?
No, it has. Okay, it is there. It is visible.
Yes, sir.
Yeah, it has come. It has come now. So mainly
Yeah.
the HCL, as you see, we have two fab lines. We have one 8-inch wafer fab line with the 180 nanometer node. Of course, the node looks a little, say, like compared to the current state-of-art nodes, a little old, but the technology is good enough for all our space applications. And when you see the technologies like which I have just mentioned, LDMOS or SIGI, we can extend this node. SIGI, mainly if I go to this node or a little modification of this node 130 nanometer, we can achieve the FT of the order of about 300 gigahertz, which we intend to do. We have already started some work toward that. So otherwise, this is good for all the logic and processing which is needed there. We have a 6-inch fab line also, which is fully dedicated to MEMS and detectors. But this line now I wanted to I want to tell you that seeing the need that we require many technologies to deliver all solutions, we are also introducing a GAN and a gas reactor to this line. The GAN and gas, as you know, today the availability of wafer is only 4-inch or 6-inch. So our GAN, though we are introducing state-of-art with an 8-inch wafer capability, the reactors are already here. Of course, unfortunately, because of COVID, we couldn't install. But I just want to convey to the users, that all the listeners, that we will not be having now only a CMOS foundry, but we will be having a good capability for having the GAN as well as gas wafers, and try to go for a heterogeneous solution. Actually, the 5G is encouraging heterogeneous solution also, and we will also try to incorporate for this as well as some other. Can you go to the next slide quickly? Of course, this is the spectrum. We are working for VLSI, photonic, MEMS, and of course, all packaging and testing reliability exercises here. And we work on some systems also. Next. Can you skip this? This I just wanted to show the complexity even in our node. So there are basically front end and back end module, and we even in this node we have 430 steps. Keep on rolling. We have 430 steps when we start from the bare wafer and we reach the final metallization. Keep on rolling. Next.
Okay.
Next. This is in fact, the some of the products, I'll say the layout wise. So using this technology right now in almost all domains, we have realized the chips, power chips, data converters, red hat, data storage, data communication, logic design. Next, can you go to the next? And these are the few chips which we have made for launch vehicle and spacecraft. Why I'm trying to distinguish is because basically, you know, when we work for space, we require red hat technology. Though the technology provider has given us the very basic baseline 180 nanometer, at SCL we have developed the red hat cells, and we have a good number of red hat cell also. And now we are capable, and we have delivered many now devices for the spacecraft as well as our launch vehicle. Our launch vehicle, our main processor in launch vehicle now is using the processor made at SCL itself. Next, can you go to the next? These are some, like we are also replacing, because space community is very conservative. So these are like standard TI devices and devices available from the other manufacturer, which our users were using, and we have made pin-to-pin replacement and delivered for space application. Next. So this is a typical, why I put this slide is, you can see it is an SoC. See, this involves a 60 core RDS, which involves 60 ADCs and 16 ADCs, and of course the required DACs are there, required LDO is there, required processing circuit is there. This is a very good 8.5 mm by 8.5 mm SoC, silicon system on chip, and being an in-house foundry, they have utilized it and have saved a lot of, I'll say, money, board area, as well as a very, very good performance, because these are all integrated. So we have capability for delivering system on chips also, and we have made quite a few now. Next. Next. So these are few imaging. This is our other area, imaging devices. Maybe sometime later we'll discuss. Next. And of course, I have tried to show a few MEMS devices, which are, you can keep on rolling, or yeah, just stop here. So related to the technologies, can you go back to the previous slide? Previous. Yeah, so you can see the color itself. So all the technologies which were needed for 5G, of course, we have not started development for 5G, but I just wanted to convey that we are working on all those technologies. We have already now developed a first cut DMOS device, which works at 40 volt, and silicon on insulator. Partially depleted CMOS we have already developed, and we are working towards now fully depleted. SiGe and BiCMOS we have started. GaN on silicon also we have started by procuring the epi wafers. Of course, as I said, our reactor for the GaN has landed, but when we install, so we'll grow the epi also here. So I'll quickly, can you now go to the next slide? Next slide. This is the soy MOSFET, partially depleted MOSFET. The earlier slide was, the next slide is LD MOS, of course, which we have developed. This is the GaN. We have bought out epi wafer, we bought out, and on that we made a GaN at our facilities, and working fine. So all this LD MOS, GaN, I'll say soy, PD soy MOSFET, and MOSFET we have developed already. And we'll be, of course, moving in the direction to deliver many more devices in the next. Can you go quickly, Gaurav? Next. Yeah, these are the actors. I was just next. Can you go? Can you go to the, yeah. So my last few slides, see, basically, we have a very good interaction with academia. And Gaurav is a testimony to that. Gaurav himself is a very hardworking, I'll say, a colleague. I consider him as a colleague itself. He is one of the, I'll say, worker who is a pioneer in this CMOS field, and working on, I'll say, technology. See, basically, there is a confusion. There is a large audience, so I want to just convey these last few words. There is a confusion that whether this country can run few sophisticated fabs. So I can just say that SCL as well as GATEC at Hyderabad and few other fabs are a testimony to this, that we can run good fabs. We have land, water, power, which is always debated, that normally it is not available in the country. We have been, and few devices and other things I have shown you, again, can build some confidence that, of course, such a fab we can work with. It is not the fab, it is the I'll say ecosystem, which is a big problem, and Gaurav has been our partner in that. Gaurav, the ecosystem involves right from design tools to the material to the I'll say fab assembly testing and putting these wafers into product. So Gaurav is very actively working on this EDA tools, indigenous EDA tools, working with us. And of course, whatever technologies like I have shown, we are developing. They need a PDK development, PDK process design kit, so that this technology can reach user and user can utilize it to a good extent. Can you go to the next slide? This is the last slide showing something. So these are the two processors which we have developed for academia. Most of you probably must have heard of Shakti processor developed by IIT Madras. It was designed by IIT Madras through open source tool. It is a RISC-V architecture. And this processor was fabricated at SCL. And he has very successfully now shown working of this processor and a few applications using this. Of course, he has now gone into another E-class processor, which can work, seeing some use cases for IoT. He has developed another processor. So we have already delivered two processors to academia, to IIT Madras, and one more to IIT Bombay, which is a Spark. Architecture is different, which is a Spark V8 based architecture, and is a 32-bit processor. All these are fabricated at SCL, and of course designed by academia. So we have very good interaction, more than almost I think 50 design chips we have already given, and through SMDP itself, a special manpower development program of MIT, we are now almost ready to deliver 100 more chips. I think that is all probably I want to convey. I'll again maybe a little more time probably would have let us interact more, but maybe sometime I request Gaurav to arrange it sometime else, and then probably we'll have some detailed discussion. Thank you very much. You can always contact me at director@scl.gov.in. I'll be very happy to share some thoughts or answer few of your queries if it is there. Thank you. Thank you, Gaurav.
Very effective. And I just say that this is precisely something we were looking from your side to deliver to the scientific community. Yes, there is a lot of, because in India, not many people know what SCL can do and what is the roadmap of SCL. So just for sharing this little bits were very, very good. So I once again thank you for nice short presentation. As per your you can say suggestion, E&ICT Academy and IIT Guwahati both I can say now will arrange you can say half-day symposium at our suitable convenient date to the Indian academia and the industries as well. So I will plan it with you and Yadana sir, and will update you later. Once again, a lot of thanks from E&ICT Academy, IIT Guwahati, and MNIT Jaipur for your valuable time. Thank you, sir. Surendra sir, if you permit, then shall I move to the next talk? Hello? Okay. So give me, so here we move to the next talk, which is being delivered by Mr. Dr. Hari Lasma. He's from the Mentor Simmons. Mr. Hari is the director of the 5G solutions from the Mentor Simmons business and has a long career in 3G, 4G, and the 5G industry. He joined the company in 2018 with Mentor acquisition of Sorocal Test Systems. He founded Sorocal Solution in 2008, and Sorocal Test Systems was spun off from it in 2014. Prior to Sorocal Test Systems, he worked as mentor as application engineer and AE manager for 10 years, and prior to that at Nokia for 5 years. He received his Master of Science in Electrical Engineering from University of Oulu, and he's the lead author of on one US patent. We welcome you very much on this FDP, Mr. Hari, and we request you to please you can say enlighten all of us with your talk. Thank you. Thank you, sir.
Hello, everybody. Hope you can hear me.
Yes.
Good. Okay, so as part of the introduction, so yes, I'm now a director of 5G solutions, mentor Siemens business. I also work on the Siemens DI software 5G portfolio. So understanding how 5G affects all the design flow from different parts of the system. So let's get started. Some introduction on 5G, or basically what it looks from our perspective. So of course, always there will be millions of devices working together. New technologies need to be deployed. But the whole point in 5G in reality is that there need to be new kind of revenue streams, new kind of industries need to be introduced to 5G. So everything needs to be connected. So this is not very simple if you think about in big scale, because if we think about, for example, factories, things are moving slow there. New factories are implemented, but also the new technologies there. It will take time. Energy, the same thing. The power plants are not upgraded to 5G in seconds. It will take time. Transportation, healthcare. So there is a lot of things and new industries, how they are working here on 5G, how they are taking into the 5G picture, and also it creates new kind of revenue streams, but also new kind of business. So the business landscape is also changing with 5G. The concept of who is the operator, who is the provider of different equipment is changing, and that's the whole point in 5G. Now we are moving into a flexible thing. One big thing in 5G in all aspects, if you start designing from the scratch or whatever you do in 5G, you always need to keep in mind the cost. 5G in some areas, for example, where 4G is good enough, people are asking why do we need 5G? So then 5G need to take into account the cost in all stages. It cannot be taken there from the scratch. So 5G is always, at least in the beginning, it's always an additional frequencies, additional technology on top of 4G. So 5G in general is changing a huge amount of things, and it's changing it actually not very quickly. If you think about the 5G timeline, it is moving ahead over the next 5 years before we even have specification ready, where we have all these different items defined. So even though 5G networks are available at the moment, it doesn't mean that the 5G will stop and we will have 6G. Okay, 6G is already been discussed what it will be, what kind of frequency it will have. But in the end, will 6G just be 5G plus new frequencies? Maybe, but well, let's see what it will be in the end. But the whole thing in this is that there is huge amount of research still to be done in 5G before it is completed. And that means everybody still there's a lot of innovation to be done still, so that everything works. The big thing what everybody understand that from 4G to 5G there is a huge difference of how things are specified and who is driving the car, so to say, or who's driving the business. Previously, if we think about the 4G and 3G, actually the research and standards were made. They were made by the manufacturers, which sometimes happened, and in many cases happened that the even though they were standards, they were some kind of proprietary parts in them. So the big vendors like Nokia, Ericsson, and Huawei basically took over 80% of the market share on every sense. And also, if you remember the old times, Ericsson and Nokia and Huawei, they also worked on the handset side. Prior, it came more standardized. So always in the beginning of the 3G and 4G waves, there were major dominance in some of the major vendors, which meant that the operators did one-stop shopping. So they picked the best from the full solutions, and they couldn't handle the cost. So basically, there was one cost from 3 vendors, and then they just competed these 3 vendors, and that's it. And they didn't really get what was needed. In 5G, operators thought that, well, this is just enough. We don't want to be in this seat anymore. We want to be the drivers of the industry. So more and more operators started involving in the research, the 3GPP standard, and then also they started looking for the network side, replacing CIPRI and OPSI, which were kind of proprietary, with the O-RAN specification and others. So the whole goal here was that no proprietary, open interfaces and more choices. So basically what they wanted is that from the beginning, everything will be the same than in handsets nowadays. So everybody can create a handset which works in a 5G network. So in the future, in 5G, also on the radio unit, antennas, distributed units, all the elements of the network could be standardized and could be used together. So then the manufacturer should take care of the interoperability between these units and have demos and evaluation platforms where different manufacturers work together. So that's what we can see now. There is a lot of like the O-RAN community, but there are also other communities run by Facebook, for example, which are completely different kind of operators, as we say. And also this leads to the point that there are integration or interoperability labs all over the world where different manufacturers can test the equipment together with the other ones. So what are the enabling technologies then on 5G, what we are looking at, and what are the problematics there? So in general, if you think about 4G, 4G is pretty good, but in 5G we need more. We need more capacity. India, a very good example of capacity where we just need more frequencies, where we can serve more people with expanding bandwidths. Speed, of course, 4G as such, if it's a good network, it can have a pretty good speed, but the new applications we are thinking of, they need more speed. The biggest problems what the 4G network has is a prioritization. So there is no way of prioritizing data in 4G. So that needs to be taken care of in 5G. Security, quality of the service, those are very important as we move forward to more defined use cases inside certain industries like healthcare and factories. Cost, well, yeah, as I mentioned already in the beginning, cost is always there in every level. And one thing, big thing is the energy. The amount of power the networks are consuming today are already huge, so you cannot spend more power. So that's one of the things what we need to do here. Of course, the specification, the 5G specification takes these into account. And if you think about O-RAN specification also, all these are embedded in the actual specifications, but how they are done, that's the separate thing. Capacity on the air is the first thing. So if we think about in general, if we think about 5G as technology now, it is existing on the air. Different frequency ranges which are coming in on 5G, millimeter waves with contents of small cells, and also having massive MIMO and beamforming for better capacity and for duplex. So all these are different kind of technologies which we need to apply on the air so that we can have as much users connected to the network as possible. So this also means that the antenna technology needs to be very, very sophisticated. Also, as these different parts are not always required and they are not cost effective, you need to know what is needed in what kind of situations. So that also makes it more complex, where you are designing an antenna and you need to understand that what kind of environment it will be working and where it is the most effective. One big thing which always, what I see 5G, and when I look at 5G publications and so on, it's not really well, nowadays little bit more is taking that how the actual network needs to be reconstructed. 4G, the 4G where you had the the antenna and then you had a radio unit and then you had the sorry baseband unit. The structure was very rigid. Of course, in 4G it was already making more flexible, making more virtual. But when you move to the virtual part and you move more and more computation to the baseband unit, it also means that the latencies which we look and the speed what we are looking in 5G, they are not possible. So new kind of structure needs to be done, more flexible, where you can have any kind of antenna system and many radio units or just one radio unit. Then you have a distributed unit which communicates with the radio unit, and the distributed unit can be directly going to the network or it can go to the baseband unit. So all these things, how you structure your network, it depends of the actual use case. So what we can see from moving to 5G is not the use cases are growing, so there is no just thing that one network anymore. So there can be different kind of networks used for different purposes. More of that later. Functional splits were the enabler of this. So when you have a flexible network, you need to have functional splits, which actually tell you where the processing happens. So currently in 4G, it's a split 8, where everything happens somewhere else than a radio, so to say. So the radio is very simple. It doesn't do much of the processing of the data, and that's how it is done today. But when we move to 5G, then the split 7.2 and 6 comes to along, where you do a little bit processing on the radio side, which means which has many benefits there. But of course, you don't want to do, in some cases, you don't want to do too much processing here, because when you have a processing power, it also means that you will lose money there. So you need to put a processor there, and that's more expensive. So it's always like you want to do less on the radio, because there is now so many radios in 5G. So less you put in the radio, the cheaper it is. But on the other hand, you want to put there some processing because in the other hand, you want to the energy efficiency, for example, might be better if you do some processing on the radio. So in 5G, all these are made possible. So you can choose where the processing happens depending on the priority of the data, how fast the latency needs to be, and so on. So all these things are there in the specification, how things can be processed. But how you use them in the real world is sometimes still not very clear. It is kind of clear that now in the first stage, the industry will be using 7.2 between the radio unit and the distributed unit, and the split 2 between the distributed unit and the baseband unit. But already now, for industrial solutions, for example, the split 6 is more kind of well, it is seen that it can be better in some ways when you don't have to deal with the timings anymore after the radio, for example. So it's not, and there is splits 5, 4, 3, or also defined there in a specification, just in case the use cases drive this. Network slicing. One of the key aspects of this is really to understand which of the data is high bandwidth, which is ultra low latency, because as you saw the previous slide, it also depends where the data is processed. So, and how big is the latency. So all these network slicing has huge effect on the network side. So how things are processed on the network side. So everything needs to be understood when you are designing different things. Okay, moving into the challenges then, how we are working on this and what's going on. So if we think about the development challenges, here are just the ones I've picked. There might be more and people are finding more, but these are the common ones where we see the biggest development challenges. First of all, the 5G spec is still changing. As you saw in the first slides, there's still many specification versions coming in, and also there is new technologies applied. So for example, algorithms are changing. So high-level synthesis is one of the big things in 5G. You need to be able to experience 5 different algorithms and the different implementations on the ASIC, how they are affecting the work, and what is the kind of different implementations of the same thing, to understand what is the best on this solution. Meaning, if you think about latency, parallelism, or you think about power and so on. So all that need to be experienced, because as I said, cost is important. So you don't want to develop something which is not cost effective, it's too good. And that leads to the next thing, is that all the time you should be able to understand not to over design. So the more you know about the environment we are building, as I said earlier, it's not just one thing anymore, it's many things affecting what you want to design. So it's not one solution fits all. So you should be always designing so that it just meets the expectations and needs of that use case, because otherwise it can be costly. Number of tests is growing all the time. That's known fact. And how you handle those from the beginning of the project, when you start testing, test plans, and how you reuse the test all over the design flow is very important. RF testing that's getting tough. What we see as a trend is that the digital part is separated and the digital part is tested separately. This means that the certain protocols like JST 204 is taken out from the chip or is taken out from the board so that you can test on the digital part of it. Main problem here is that the kind of antennas you will be using, it's not necessarily available at the time. So you are designing ASICs for future use, and then means that the you don't necessarily have the different kind of antenna streams available from RF. So you need to create them by hand using MATLAB or other tools. So different kind of RF streams, different kind of antenna streams to your radio unit. Same thing on the other hand on the handset side. So you can create different kind of IQ streams handset without the RF. Power optimization in all stages. As said, the energy is important. Whatever you are designing, if it's handset, and now, especially now you're doing the radio units and distributed units, you need to understand how the power is optimized, because also the antennas and especially the radio units, they are small. You need to understand that there is not too much heat there and so on. And sorry. And then there is antenna design, of course. Antennas, there's multi-mode antennas, a lot of new kind of antennas. You have Bluetooth antennas, you have 5G antennas, 4G antennas on the handsets. So in handsets, you have so many different antennas. Also, different kind of antennas on the network side work in different areas the best. So there is new kind of antenna technologies which are very effective in some areas, and some technologies in other areas. So that's a big thing on general what's the antenna design. Then RF meets high-speed digital. So this is big thing if we think about in or in a board level. We think about how different the RF has different characteristics totally than high-speed digital. And high-speed digital now, I mean 25 gig, 50 gig speeds on the other side, and these are on same PCB or even on the same ASIC. They are on the same die or so on. So this has huge effect of how you optimize things and how you make sure that these things work. And then all of this, if you think about what I just spoke about, the challenges, it's just that the growing amount of dependencies, that's really the main point. So if you think about in 4G, as I said, it's kind of one network, one kind of devices there on a network side and device side on a handheld side. So it means that the board design was pretty simple, and the RF SoCs and digital SoCs were pretty simple. You basically just have a dependency to the next level, to the device and board need to work together, and SoCs and the board need to work together, for example. So it was always very, very simple. But if we move to look at the 5G, everything depends on itself. So let's talk about the 5G network. So previously you had a one 4G network. In 5G network, you can have private networks, which means you can have any kind of networks. So it means that in the let's take two kind of different ends of the network. So in factories, you have a network, or if you think about a chip, you can have a 5G network there. It can be private network which has its own characteristics. In a chip, for example, it can contain a lot of IoT work, IoT traffic, and in a factory it has machine-to-machine communication a lot and IoT data. That's completely different of if we think about network in the downtown Delhi. So there you have machines, you have people, you have everything possible there. So if you are designing an SoC to that network, it's completely different than you are designing it to the factory. Because if you use the same SoC you are using in a public network in dense area, in implementation on a factory, that's too expensive. That's the whole thing. You could use it, no problem, and the people will use it in the beginning, especially. But when you start building an optimized factory network, for example, you will have to have the designs from the SoCs, boards, radios, antennas, everything specially designed for factory automation. Then it is cost effective and it works the optimal way in there. You can optimize the speeds, you can optimize the coverage areas and so on. So really that's the big difference between 4G and 5G, is that 5G is so flexible, so you need to take the advantage of the 5G flexibility, and that means that it needs to follow you the whole thing through. This means, for example, when you are designing a digital SoC, let's say, you could have a model of the network of the factory modeled, and you can have how the ray tracing works there, how different signals are behaving. Well, that's very important in 5G, how signals are behaving, because the millimeter waves are not reflecting the same way. And you need to understand how the coverage is done, and then you can have input directly from that network or the model of that network and feed it back to your digital SoC. Just an example of this. And also on the other areas, the same similar kind of things. The more you know about where you are designing, the better you are. So the whole thing is this. So there is 4 kind of domains in the design. So there's a chip domain, there's a board domain, there's a device domain, where I mean really it can be a car, an antenna, radio unit, mobile handset, or whatever which has the mechanics around the board. And then there's the network aspect. And if you are able to handle all these 4 domains, then it makes your whole flow simpler. Especially in 5G, where these different effects happen all the time. So network effects have an impact on board design and all these around. And the data management is of course the key. So the more you get data from one source and bring it to the other one, the simpler it gets. You don't have to recreate things, because in 5G there is a million things you need to create. So you don't want to invent things twice. You want that everything works together very, very closely. So there is no overhead of creating. Well, it's not only the design data, is always the test data also. So how you manage the test data around different levels of integration. Because it's always interactive. So even though I said in the beginning that, okay, you can model the factory, you can have the model of the factory and get input from that to the chip design, for example. But on the other hand, you should get also input from the real network, so that when you are designing the next chip, you have more accurate data of how the models work and so on. So all this is a loop. So everything has an impact to the other one. And the more design data you have and you can manage that nicely, then you can always have a better solution. So that's what it really is. It's all about data management and the communication between different groups and different devices, different networks. And first of all, if we think about this, this is a picture which, if we think about Nokia, Huawei, and Ericsson, this is all happening inside one company, or could happen inside one company and between their customers. But if we think about 5G, what the operators wanted in the beginning was that these are interoperable. So it means that when we can have a good data management, we can exchange information in a correct way. The chip manufacturers can be separate entity, the board manufacturers can be separate entity, and the device manufacturers can take the chips and boards wherever they need those and create the devices they want, and those work in the network. So also there's a big thing in here to get these all integrated, get all things done. That leads to the point why Siemens acquired Mentor. Also leads to the point why Siemens is interested on 5G and why we work here. We have a huge amount of tools. We have a huge amount of tools in every level of the hierarchy. So we have in the chip level, Mentor is very good on digital side. We have Catapult, which is a high-level synthesis. We have Questa, Veloce, working on the as a powerful engines where you can connect real kind of environment. So you can create the networks you can create already on the pre-silicon phase. You can have Hycon, Vista, which are high level, where you can abstract the processors to a higher level, and Xstep, which can then run post-silicon, the same cases you created pre-silicon. So the full flow of creating a 5G chip, it's existing there, and verifying that. In analog and RF, we have AFS and Symphony, therefore verifying that part. So on a chip level, there's a lot of things Mentor does. On a board thing, basically that's where Mentor and Siemens kind of collide, and where the actual integration is happening. We have Expedition and Hyperlinks working on the board design, and SimCenter can bring in the device level information. And Xstep, of course, doing the verification of the board. Device level, SimCenter is the main brand. Under that, there is many different tools to do device testing for heat optimization, for 3D electromagnetics, all the wave of mechanics and so on. So all that can happen there. And then on network side, we have Xstep, all these doing the verification. We have SimCenter, also on network side, doing the network planning, what I was talking about, and Technomatics, which actually does, for example, industrial layouts and so on. And in data management, we have Teamcenter and MindSphere, where you can exchange information, store information, manage information. So this is really point why Siemens is here, why we want to see this, because we have all the tools and also data management around the full flow. In some cases, and previously this was split into two, so that the chip and board were kind of different, and the network and device were different vendors there. But the whole point is here that right now, for example, in XStep, we are working on getting real IQ data from real environments directly to XStep, so we can play it on the chip side. This means that we have all the fading elements, fading parameters done in a real environment here on a SimCenter Technomatics environment, and we can bring that data in already to the chip level. And this is really important 5G. As I said, everything is cost, and also in cost, the big thing on the cost is the price of the equipment, but also the energy consumption. So in all levels, you should be able to check that, okay, what is the power consumption on this area? And these tools are also designed in all areas to optimize the power, and also to be able to create software which optimizes the power in the beginning, from the beginning. So these are the main solvers what we have: Catapult, SimCenter. Really, if we think about over designing, it's really of knowledge of where you are designing, what kind of things you are. That's really the point. Already said in a previous presentation about, of course, about the materials in SoC, for example. That's really, it depends on where you're designing, what kind of frequencies you need to use in certain areas. Even on that, you need to understand what it is, and you should not over design. You should use those materials, so those flows which are feasible for that kind of implementation. XStep, that's my specialty. We are working on the number of tests, so interoperability, to be able to change the test between the units. So for example, the chip manufacturer can bring in test suites for the board designer and so on. So there is reuse all the time happening. RF testing, that's what we see. We are doing digital testing because basically all our customers seem to understand that the creating end-to-end testing where you have the RF parts, digital parts, it's okay, it's doable, but it's very expensive. And it's just easier to validate the digital part and the analog part separately, and then just run few tests which test the full flow, see that, okay, they are communicating to each other. Power optimization, all levels. From the beginning to the end, you need to understand that all the devices, they need to have all the power optimization happening there. And when you have power there and you create heat, how to get rid of the heat. Because earlier, okay, and right now in the phones and so on, of course, the heat is a big problem there, but the heat is becoming a big problem also in the radio units, where you, as said, there will be more processing happening on the radio unit, and the radio units will be smaller with a very tight packaging sometimes. So you need to understand how to get rid of this heat if the heat is happening. And then it goes all over power optimization on the network level and how 5G helps you with power. Dependencies, I talked a lot about that. We have a lot of tools which can communicate together. Antenna design, yes, that's one of the key aspects here. How do you have the antennas? When you have a small box, how do you place the antennas? for example, in a handheld? How do you place the antennas on the IoT device, or robotics? Where do you place them? How do they reflect there? How do they work? How do they communicate? And also new kind of antenna technologies to overcome the problems you have on 5G when, for example, the signals are not going through objects and so on. And in the end, RF meets high-speed digital. That's one of the key aspects in the future, especially when you're going more and more dense designs where these two things are very close to each other, all the problems they can cause to each other, basically. Okay, that was my part, what I had to say. If there's anything you want to ask, please send me email. And also on these tools and sets, what we are talking about here, I can guide you to correct directions. I'm not expert on all these, so we can guide through this. Thank you.
Thank you, sir. Good afternoon, sir. Sir, actually, Gaurav sir is not available right now. He's been invited for a talk. So, sir asked me to give you a vote of thanks. So, on behalf of E&ICT Academy, IIT Guwahati, MNIT Patna, MIT Patna, and IIIT Jabalpur, we thank you for such a wonderful talk. Thank you, sir. The Q&A session.
I am here.
Okay. Yeah. Thank you, sir.
Okay. Yeah. So the talk is over, right? So, hello.
Yes, sir.
Hello. Yeah.
Yes, sir. Yes, sir. Please, sir.
Yeah. So Harry, we really thank you a lot for such a nice and wonderful talk. It was really enlightening to me. The way you have you can say described the 5G development and the issues related with this. Now I request the participants to please raise hand, and Ms. Froja will coordinate asking questions in a 5G area. Okay. So any question from the audience side, please raise hand, and I request Mr. Harry to please, if you please address the queries of the participants. Thank you. Hello. Hello. Roja, am I audible?
Yes, sir. Yes, sir. You're audible, sir.
Okay. So Mr. Manak is, you can say, his raised hand. So there are many hands on there. So can you please, you can say, coordinate this activity so that they can ask the queries?
Yes, sir. Sure, sir.
Yes, Mr. Manak. So you has been unmuted. You may please put forward your query. Sir, there are a few questions, sir. They are in the Q&A section, sir. The first question is, sir, how to use Catapult?
Mr. Harry, this is a question to you.
Yes, Catapult is a tool where you have the algorithms in the C code, and from that C code you can automatically create RTL code, which can go on chip. There is multiple ways of doing it, meaning that you can choose very quickly of you can optimize on power, on speed, like parallelism, and or you do serial. You can check how big the design is and so on. So it's a very powerful tool, and what we see is in 5G algorithms, most of our biggest customers are using it for 5G, and especially for the algorithm development. We can, I think there is Patri, he's present on this call, so I think can connect you with the Siemens team, and it can be integrated to Vivado, so it can be used also on FPGA side. So there is links to the FPGA also on Catapult.
Sure, Hari. This is Om. Hi, Firoja. This is Om. You can direct my email to the person, and I will address and take it forward on the Catapult side.
Yeah, I'll put it here on the answer side, the Om's email.
Thank you, sir. So there is the second question again for 5G. Any link will be provided by the Siemens team. So I think so that is also. Hello, Gaurav sir.
Yeah. So yeah, you are right, Roja. So any queries which is regarding the tools also, you please write directly to Mr. Om Batri, and his email ID will be provided in the chat box for the question answer session for your kind perusal and ready response. So that is all there. So any more questions? Hello?
Yes, sir.
Roja?
So what is the yes, sir. What is the impact or what impact will 5G technology have on medical sector?
Yeah, on the medical sector, I think there is the first thing is always the remote surgery, remote e-health, and so on. I think the main points is that, of course, it still needs a lot of development, that we have a very stable connections between the different locations where things are happening. So that's one of the things where you could remotely do even remote surgery. You could do, but also already many kind of doctors' appointments can be done remotely. But also what I see is the IoT could work on health, because you could have sensors located in patients outside, measuring different kind of movements, positioning, and so on. So for example, if you have because if you think about very simple thing, if you have a patient in a doctor's appointment, he can look very good on knees and wherever, or movement, he can move nicely. But if you put sensors and leave them on for 24 hours and you monitor them, then you know much more how people move and how they behave. So basically this kind of a monitoring of people over the longer period can be done on 5G. So and other things like monitoring health and so on, what's already happening, could be online and directly connected to your doctor, for example. So your doctor directly gets feedback what's happening. So there is a lot of possibilities what 5G can offer for medical and healthcare.
Thank you, sir. So the next question, it is possible to give a training for the Catapult EDA tool?
Yeah, Proja, we will arrange it from E&ICT Academy, I think.
Yeah.
So Firoz, I will take. We have some mechanism
Yes, sir.
to provide. Yeah, so you can direct those to me.
Okay, sure. Thank you, sir.
Yeah. And regarding this particular, the usage of the 5G in the health systems, so there are a lot of real-time sensor data analytics and can be done in the real-time mode, and a certain predictions of the diseases can be done with the help of the sensor data. And in case of emergency, it can be connected to all the nearby life-saving, you can say active life-saving actually modules like hospitals. The paramedics also as soon as possible so that the pressure lives can be saved. This is one more example, or like what Harry has said. Thank you.
Thank you.
From my side.
Yeah.
So I think we have done most of the questions. So let's conclude this session here. And in this session, I really thanks Mantle Simmons for providing us an opportunity to host you once again. And thanks a lot, Mr. Harry Rasma, for such a nice talk on this, on the 5G. And I really thank Mr. Om Mantri to help us, Mr. Viresh Shetty, to help us organizing this talk, and Ms. Nair for the kind support as well. So with this, with the permission, I really I conclude the session here, and we will begin again in next 10 minutes, where we will start talk by Professor Ratin Bhattacharjee. Okay, so we can have a 10-minute break, and we actually can go ahead with this. You actually can we can go ahead with the actual schedule which we have proposed. Thank you, everybody. Thank you, Mr. Om. Thank you, Mr. Harry. Thank you, Ms. Verma, and thank you, Mr. Viresh Shetty, and all the experts, Dr. Aditya, Mr. Ashish, and Mr. Puneet for your kind presence. And all the participants join us back in 10 minutes. We are going to start in 10 minutes. Thank you.
Good afternoon, all. So we are about to start the third session of today. On behalf of Dr. Gaurav Trivedi, sir, would like to introduce Professor Ratnajit Bhattacharjee, sir. Ratnajit Bhattacharjee, sir, joined IIT Guwahati in the year 2002 and is currently working as a professor in the Department of Electronics and Electrical Engineering. His research interest includes wireless communication, wireless network, microstrip antennas, microwave engineering, and electromagnetics. He is a co-authored about 160 research paper. 13 research students have completed their PhD under his supervision. At present, several research scholars are working under his supervision on the topic of antenna design, high-frequency microwave tubes, millimeter wave communication, chip-based communication system. He has served as a general chair of the 5th edition of IEEE Applied Electromagnetic Conference, AEMC 2015, the 22nd National Conference on Communication, NCC 2016, Chairman of the 18th National Application, VEDA 2018. He has also served as a convener for the conference IESC 2017. Innovation in Electro Engineering, IIT Guwahati. He is also he has served as head of electronics and electrical engineering IIT Guwahati from 2011 to 2014. He has delivered invited talks and number of conferences, symposium, and workshop. He has developed a web course on electromagnetic theory and MOOC video course on microwave engineering under MPTL. He has also involved with several projects. He is the Institute Coordinator for the ongoing Virtual Lab project of MHRD. He is a member of the RAC of Samir. Presently, he is also the Chief Investigator of Electronics and ICT of the MIGHTY Initiative project for setting up the Electronics and ICT Academy at IIT Guwahati. He holds a PhD in engineering from Jadavpur University, Calcutta, and an MTech microwave engineering from IIT Kharagpur. He did his BE in electronics and communication engineering from RAC, presently known as NIT Silchar. Sir, having several journal publication as well as research publication in the area of microwave RF design, micro antennas. So with this, we would like to invite Ratnajit sir to please start the session. So Gaurav sir is in a meeting, so sir requesting me to, yeah. Yeah, Gaurav sir, please.
Sir, thanks a lot, Ratnesh sir, for agreeing to deliver a talk in this FDP, and I welcome you in this FDP, and I request you to please deliver the talk, and I will be joining this session in couple of moments. Thank you, sir.
Sir, I request you to please check we have given the presenters right.
Yeah. Thank you, Dr. Gaurav. Thank you, Firoza, for introducing me. Can you hear me properly?
Yes, sir, we can hear you properly, sir.
Okay, thank you. I once again welcome all the participants to this lecture, and good afternoon, everyone. You already had 2 sessions from the experts from industry and R&D labs. And as Firoza is introduced, I am basically a communication person. So this talk, I have specifically prepared to give an overview of expectation of communication community from the designers of integrated circuits. What are the issues we are facing and how you can solve it? So let me go to the talk. So I am keeping my video off to save the bandwidth. I am keeping my video off. Firoza, can you see slides?
Yes, sir. We can. The slides are visible, sir.
Okay. So the topic of the talk is millimeter wave and 5G, opportunities and challenges. So if I summarize the theme of the talk, 5G wireless communication or next generation of wireless communication, they will utilize this millimeter wave band of frequencies. And the communication that is we are expecting to have lot of challenges because of the use of millimeter wave band and other I should say the target parameters of the 5G systems. They will put lot of research and for the RF front end and ASICs, and it will give us ample amount of opportunities for expanding our communication paradigm, provided we can solve the challenges. So with this background theme, I am positioning my talk, and first few slides will be just a review of 5G communication, and then we will go into the millimeter wave, and then I will try to talk certain things or certain developments. These are needed for 5G to include millimeter wave frequencies and what impact it is going to make on the RF front ends and ASICs. So this is the whole theme of this talk. So 5G wireless system, it is essentially refers to the set of technologies which satisfies ITU's IMT 2020 requirements and 3GPP release 15 specification. Now, if you look at the emergence of the wireless communication technologies, which started with analog phone calls, then mobile communication started, key differentiator was mobility, then we went to 2G digital phone calls, and this is the period where it was secure and mass adoption, but the data rate was limited, and 3G phone calls, messaging and data, better internet experience and broadband. However, the way 3G was advertised, it could not deliver. Then 4G, we moved to IP-based services, faster broadband, lower latency, and then next, what we are looking for is the 5G or the coming generations. As Gaurav has mentioned, people are even started talking of 6G. So if we look at the current scenario, the 4G, the peak data rate of 100 Mbps for high mobility and 1 Gbps for stationary or pedestrian user. User plane latency less than 10 millisecond, scalable bandwidth up to 40 megahertz, extendable to 100 megahertz, and downlink peak spectral efficiency is 15 bit per second per hertz. Uplink 6.75 bits per second per hertz. So these are the current 4G standard they target to deliver. Now, when we move from 4G to 5G, what is going to happen? So this inner one is the IMT advanced or the 4G standard, and the outer one is the IMT 2020. So we see that we target a peak data rate of about 20 Gbps. The user experience data rate 100 Mbps, spectrum efficiency increase by 3 times, and mobility from 350 to 500, latency or the delay from 10 millisecond to 1 millisecond. It is going to be hugely connected. The density of connections are going to be very high, 10 to the power 6 devices per square kilometer. Network energy efficiency we need to improve by a factor of 100, and area traffic capacity also will improve from 0.1 to 10. So these are the expectation from the standards, and we'll look into it how we are going to solve these issues. Now 5G is expected to be deployed somewhere in this 2020 to 2021. Before that, it has gone through several product prototypes, standard, and then evaluation, and finally we are waiting for 5G to be delivered. So I'll not spend much time on the 5G issues as such, but I must say that these specifications, where what we have mentioned in the IMT, these specifications, the communication engineers, they are trying to solve in their own domain some of the issues, and definitely some of the issues will be very, very dependent on the development of semiconductor technology, ASICs, and RF circuits. So if you look at the 5G expected system architecture, at the core of it, it is 3D MIMO or massive MIMO. This is what people are talking of. Massive MIMO will use very large number of antennas at the base station, and then you can see the millimeter wave links. They will cover hyperdense small cells, then it will V2X communication, D2D communication, then there will be relay networks, Wi-Fi offloading, cloud computing. So 5G will integrate all these things in a, try to integrate all these technologies under one umbrella, and millimeter wave backhaul or millimeter wave connectivity is going to play a major role in 5G. And this is the topic on which I will talk, and certain issues that are arising or being discussed on the use of millimeter wave technologies for realizing 5G. Please note that 5G is just not millimeter wave. 5G are already operating in sub 6 gigahertz band. And as I mentioned in the morning, in India also 3.3 to 3.6, that frequency range has also been identified. There are IoT services which will go even less than 1 gigahertz frequency. But what people are waiting for is the use of millimeter technology for the 5G. And the reason, as you know, that as we try to send more and more data we require large amount of bandwidth. Now, what happened? This bandwidth in the sub 3 gigahertz or sub 6 gigahertz band, these are almost exhausted, these are allocated, and if you go to the lower frequencies, you do not get enough bandwidth. So there is a push to going towards higher frequencies. I take this opportunity to tell one thing. The millimeter wave band we are talking of, and many of you might be aware that Professor J.C. Bose, so this is a paper published in IEEE Transaction of Microwave Theory and Techniques in 1997, after the 100 years of J.C. Bose research experiment, and work of Jagadish Chandra Bose, 100 years of millimeter wave research. So we can say that millimeter wave research originated from India. Just 100 years ago, J.C. Bose described the Royal Institution, London, UK, his research carried out in Calcutta, India, of millimeter wavelengths. He used waveguide horns, antennas, dielectric lenses, polarizers, and even semiconductor at frequencies as high as 60 gigahertz. He used, of course, spark gap generator. And this is also being echoed. He developed the use of galena crystals for making receivers. And Sir Neville Mott, Nobel laureate in 1977 for his own contribution to solid-state electronics, remarked, J.C. Bose was at least 60 years ahead of his time, and in fact, he had anticipated existence of P and N-type semiconductors. So this is something great. Someone some 125 years back started working in millimeter wave, and this was, of course, basic research, and now we are trying to go for commercial use of that technology. So several bands have been identified for millimeter wave applications. So this is N257, 258, 259, 260, 261 is a subband. Now these are these LMDS bands. It was for digital TV around 28 gigahertz. Then K band, V band, K above band 39 gigahertz. So these are the band of, these are the center frequencies actually, and we are looking at a, for example, uplink and downlink frequencies, and we are looking at bandwidths. Please remember that around 40 megahertz was the bandwidth in 4G LTE. Now we are talking of 100, 200, even 400. Now a small calculation, if you come over here, we are targeting a data rate of 20 Gbps. And if I go back, the 4G spectral efficiency is around 15 bit per second per hertz. So with 400 megahertz bandwidth, it will amount to 6 Gbps, and to reach 20 Gbps, we need to increase our spectral efficiency by at least a factor of 3, which is mentioned in the IMT document. Now, how do we increase the spectral efficiency? There are many techniques. I am not going into that. The communication technologists are aware of many of these techniques. Let us come to some basics. what problems and what advantages millimeter wave is going to give. Once we understand that if we go to millimeter wave band of frequency, we can support huge amount of data rate as high as 20 Gbps as envisaged in the IMT 2020 specification. But let us come to this equation, which is a very celebrated Friese equation. It tells that the received power at a distance r, it depends on lambda square. As we go higher and higher frequencies, our lambda decreases and we receive less power for the same range r. If we want some specific power to be received, our range should be reduced. So this is one of the major limitation as we move to millimeter wave frequencies. If we use, then we will have to do something over here. The GT and GR, the gain of the transmit and receive antennas, these are to be adjusted, and we'll see that. So this is one issue. With frequency, the range reduces, the received power reduces. Also, the noise power, it depends on the bandwidth. Higher the bandwidth, it will pick up more noise, and roughly we can say KTE, T is the equivalent system temperature, noise temperature, and B. As B goes up, noise power increases, and if you take the ratio, the received power to the noise power, the SNR goes down. So this is one of the major challenge. How do we try to tackle this challenge? We go for beamforming, but then it will have its own limitations. Once you do the beamforming, you will have directional beam. It will be very much sensitive to blockage. The millimeter wave frequencies get absorbed in the atmosphere. So all these challenges are there. Another challenge, if you have noticed, we are trying to increase the mobility and at the same time increase the frequency. Another parameter, it is the Doppler shift, which depends upon the velocity, rather the relative velocity between the transmitter and receiver, and also the wavelength of the signal. Now, as the wavelength goes down and the velocity increases, the maximum Doppler shift, it increases. Now, how does it affect? Doppler shift in multipath environment, actually we have two things. One is the delay spread of the signal because of the multipath, and another is the Doppler shift. Now, the delay spread has been taken into account by going for multi-carrier or OFDM type of approach. But if you have very large Doppler shift, then the inter-carrier, there will be interference, because this shift is not going to be a fixed shift. This will be changing rapidly as the direction of movement changes, and inter-carrier interference will become a major issue. Communication people are trying now processing signal in the delayed Doppler domain. People are talking of modulation schemes like OTFS. So this is another story, of course. But please remember that whenever you go to the millimeter wave or very high frequency band, and also when very high speed vehicles or high mobility, the Doppler becomes a major barrier. And the time for which you see the channel steady, it is related to the Doppler, we call the coherence time. massive MIMO is emerging as one of the solution because it has been shown theoretically and also to some extent experimental verification has been done that the channel variation can be reduced to a considerable extent by increasing the array size. So the trend now is use more number of antenna elements, and also you combine the power of multiple antennas to overcome, to increase the gain and to overcome the range limitation introduced by millimeter wave. Reduction of the wavelength have some advantages because many of these components what we use in the RF front end side, starting from antennas to some other circuits, these are wavelength dependent. As the wavelength goes down, they become smaller and you can integrate more number of components on the same area. So this is an advantage which is being offered by moving to very, very high frequencies. Of course, if we can solve the other issues. This is a generic wireless transceiver layout. I think almost all of you are familiar with it. We have an antenna, which may be a single element or an array. We have a diplexer. In most of the mobile transceiver, we use a switch. Then we have a low noise amplifier. We have a band pass filter. We have power amplifier in the transmit change. And then frequency synthesizer or local oscillator. And then we have the mixers. So the RF front end will comprise of these components. And if you take a more detailed look into this, we have the RF analog. So this is very, very important. RF is analog. Then analog front end, where the conversion takes place, where we have the DACs and ADCs and PLL, and then we come to the digital modem implementation, which may be FPGA, DSP, or other platforms. So you can see that in a communication system, as we move from baseband signal to the transmitter, we come across different types of signal processing activities, and naturally you will have the platform doing this is also different. Now, some of the semiconductors technologies are more suitable for performing some of these activities. I will come to that slightly later. So once we understand that each of these elements are going to play critical role, and particularly when you go to millimeter wave range, all these issues are to be addressed. So we use large antenna arrays for beamforming to compensate for the higher path loss. Now, when you use an array, how you use an array, this is important. Many parallel radio chains, both for the transmitter and receiver. Design complexity and building practice must change dramatically. So this is what is needed. Millimeter wave systems with many parallel transceiver and antennas put stringent requirement on power consumption, heat dissipation, area and volume. Area and volume constants are imposed by the antenna separation due to short wavelength at millimeter wave frequencies and limit the size of the active parts. So I have already spoken about these issues. Now, when we say beamforming, there are many options. So let me start with the very basic one. And this particular paper, written by Thomas Cameron, Bits to Beams, RF Technology Evaluation for 5G millimeter wave radio, it gives a very, very beautiful introduction to these topics without going much into the mathematical issues. And it gives a conceptual understanding of the challenges that are there. I will refer to this paper in many parts. So at RF, single RF path is split into several paths, where the beamforming is done by controlling the phase of each path. So you have phase shifter in each path, and you can change the phase. And for example, if you consider transmit, so you go this way, the signal, same signal is given to each antenna element, but it is shifted in phase, and then you form the beam in the far field in the direction of the intended user. So by controlling the phase shift, you can actually steer the beam in the direction of the intended user. Also, this type of, those who are familiar with the array pattern function, they might have noticed that when we go for this type of phase shifting arrays, we can produce nulls in several directions, so we can reduce the interference signal pickup from the unintended user. Beam direction control by a series of phase shifter in the RF domain, but the issue is supports single stream transmission can serve one user at a time with this architecture. Now, maybe this beamforming will be done for a given amount of time to a particular user, and then we'll shift to another user if we want to accommodate more number of users. So it has to be done at a very high speed. The next architecture, people talked about smart antennas, smart radio for a long, long time. This beamforming is performed digitally. What it means that first the signal, it is picked up, and then it is down converted. It is A to D converted. Now you have the I and Q signal here, and then in the digital domain, you multiply them with a set of complex weights, and then you try to form the beam. So there are a lot of algorithms, signal processing algorithms available for doing that in an optimal manner. From the system point of view, what you see that here you require the transmit RF chain per antenna. So if you try to increase the number of antenna elements, you need to have large number of independent RF chains, and this approach, although it delivers highest capacity and flexibility, it is a very costly proposition, and it is at the same time very, very power hungry for large scale antenna arrays, particularly at millimeter waves. So what is the solution? On the one hand, if we go for analog beamforming, we cannot process, we can serve one user at a time. Our hardware RF circuitry, it becomes less. This provides the flexibility or doing beamforming simultaneously, but at the same time, you have a large number of RF chain adding to the cost and power consumption of the system. So that's why the industry and the academia started thinking of something in between, and that has become very, very important today. And lots of literature are being published, and various architectures are being explored, and this is called hybrid beamforming. So hybrid beamforming, simply put, we have number of RF chain much less compared to number of antenna elements. And in signal is first digitally pre-coded, so some signal processing activity is done here and passed through the RF chain, and then processes in analog phase only pre-coder. So next processing is done here. So these are denoted by FDB and FAB. And what we notice that this NRF, number of RF chains, is much less compared to the number of antenna elements NT. The main objective of the hybrid beamforming design is an architecture properly partitions between RF and digital domains through a set of precoding weights and RF phase shifts needed to meet the design goal of improving connections between the base station and the user equipment. And this is in very, very focus today, and we will spend some time understanding it. So hybrid beamforming comes under two flavors. One is fully connected and another is sub-connected. So here you can see that you have the antenna arrays in the sub-connected, total NT antennas and NRF RF chains, so NT by RF antennas and then phase shifted, and this essentially is a analog beamforming unit repeated. Whereas hybrid beamforming, we have the RF chain connected to each and every antenna element, and you have this structure different from this, and each RF chain is connected to NT phase shifter, total NRF into NT phase shifter. So for sub-connected hybrid beamforming, NT number of phase shifter, and each RF chain is connected to NT by NRF phase shifter. Fully connected structure provides gain. Now, if you go for this, it provides a gain in spectral efficiency over the sub-connected, but at the expense of more power consumption. So people have analyzed these systems thoroughly, and you can refer to this paper by Irfan Ahmed and et al., Survey of Hybrid Beamforming Techniques in 5G, published in IEEE Communication Surveys and Tutorials, and it is a very, very elaborate paper. Now coming back to our old paper, Bits to Beams, this is hybrid beamforming shown with sub-array type approach, and this part you can see it is essentially an analog beamformer. So this is being stacked. By directing power towards the intended user with narrow beams, base station can reuse the same spectrum simultaneously to serve more than one user in a given time slot. Sub-array approach shown here is most practically implemented and is essentially a step and repeat analog beamformer. Currently reported systems from 2 to 8 digital streams in practice, which can be utilized simultaneously to support individual user, or alternatively provide 2 or more layers of MIMO at a lesser number of users. So this has already been evaluated, this architecture, in the industry. Now you can see that at the heart of this beamforming is this block, and we'll see to some detail this block. So this is actually a complete system considering fully connected beamformer. So this is how actual system will look like, both transmitter and receiver. Now coming back to this is an interesting division. You can see that this particular block, if you take and expand here, you can see these are lot of power dividers, and then you have the power amplifiers, phase shifters, factors including what type of segment you are going to cover, what range, what power level you are going to radiate, the path loss, thermal constants. There will be a variety of transmit power level required to address deployment scenario, ranging from small cell to macro cell. So there will be lot of variation in the design of this unit. Whereas if you look at carefully, you have got the millimeter wave signal here. You have the digital signal ADDA, and then when you have the oscillator and you have shifted it, you have actually moved the bits to millimeter wave, and this architecture does not require that much of flexibility as that of the RF stage or the beamformer will require. Now it is very, very important to consider the selection, because the most power amplifiers and LNS, they are going to play critical roles, and selection of power amplifier technology is based on the combined consideration of transmitter power, gain of the antenna, which we can say that number of antenna elements, and RF power generating capability of selected technologies. Now you have a host of technologies starting from CMOS, CMOS SOI, then you have silicon, germanium, gallium arsenide is currently mostly used in design of power amplifiers. Then gallium nitride GaN technologies coming up. So host of these semiconductor technologies are there, and the design of the system requires choice of appropriate technology considering the targeted application, the number of antennas you are handling, and the approach also becomes different. For example, if you look at CMOS, it can handle lower power level, but if you consider large number of antenna arrays, you can achieve same amount of power. So we talk in terms of EIRP, effective isotropic radiated power. It is PT, the power transmitted, and GT, the gain of the system. So these curves have been plotted for different EIRP levels, and so they've come to a conclusion that when you are trying for lesser number of antennas, and desired EIRP may be accomplished with fewer antenna elements using 2 to 5 technologies and low integration approach, or by using silicon based, which is high integration approach, lower power, and then you have large number of antenna elements. Each approach has advantage and disadvantage. Practical implementation require trade-off of size, weight, DC power consumption, and cost. So this is a major issue. This is and will remain as a major issue for quite some time. How to design the RF front end, the beamformers, because the moment you will move to millimeter wave, you will have to have large number of antennas, and design of RF front end with large number of antennas satisfying the requirement of power, range, and then the size, weight, and other engineering aspects. This is going to be a big challenge. I come to another aspect which is also very much pertinent. This is the phase noise related issues. So a critical property of the local oscillator is the phase noise, frequency domain representation of random fluctuation of phase of the local oscillator signal waveform. And ideally, an oscillator is to give power at a particular frequency, but we know that there will be power away from the carrier frequency. So it is measured at dBc per hertz at a given offset frequency delta f. Now, how this is going to effect of phase noise in a receiver is to degrade both signal to noise ratio, which or bit error rate. Because if you consider, for example, a QM type of constellation, and if you have a phase noise component there, the EVM, so that will actually degrade, giving rise to higher bit error rate. And also it affects the selectivity. The impact of selectivity is usually most severe. Phase noise degrade receiver selectivity by causing down conversion of signals located nearby the desired signal frequency. So if you have, because of this cut, it will not only convert the desired frequency, it will also pick up signals which are adjacent to the signal frequency, and it will bring it to the bandwidth of the system. There is one celebrated equation, Leeson's equation. Now, phase noise increases roughly 6 dB per frequency doubling. So you can see that as we move from sub 3 or sub 6 gigahertz to millimeter wave band, the phase noise will increase tremendously, and technology must come up to keep the phase noise under control. Phase noise increase at millimeter wave is also caused by degradation of local oscillator resonator, the voltage control oscillator or VCO quality factor. And from this equation, which was of course formulated considering a theoretical model of a oscillator, to achieve low phase noise, Q and output power must be maximized while minimizing the noise figure of the active device. All these three factors contribute in an unfavorable manner. You cannot improve one, all these things independently in a as the oscillation frequency increases. So we are talking about the beamforming system, power amplifier, oscillator. Apart from that, there are other issues called the passives, because you invariably will have the inductor, capacitor, transmission line, and transformer. And the issues, the value of the inductance, the Q, self-resonant frequency, this comes into picture. When it comes to transmission line, I'll go to this particular reference. Millimeter wave CMOS digital controlled artificial dielectric differential mode transmission lines for reconfigurable ICs. And this is in short called DCAD. And what they claim, this paper is the first to demonstrate the concept of a digital controlled artificial dielectric DCAD millimeter wave differential transmission line using standard digital CMOS process. The unique element can be used as the basis of reconfigurable integrated circuit design for low cost, multi-band and multi-rate millimeter wave system. Regarding passives, there have been more observations. The fundamental ones I will discuss. Just give me a while. Two things. One is this paper, they discuss about the various energy loss mechanism become important at millimeter wave frequencies. Unlike most other compound semiconductors, silicon substrate is conductive in modern integrated circuits. This conductivity causes energy loss due to magnetically induced eddy currents. It can also result in a considerable energy loss in addition to the energy loss in metallic conductors. And passive devices also suffer from energy loss due to their finite conductivity. Skin depth becomes an issue. And apart from that, they mention about another issue, an equally important effect that is given little attention is the high dielectric constant of most semiconductor substrates, including silicon, epsilon r 11.7. The rectangular silicon substrate forms a dielectric waveguide that can sustain propagating mode depending on the physical dimension. Unfortunately, many of the natural modes of typical silicon die will fall in the middle of the millimeter wave band of interest. This in turn creates an alternative mechanism for energy loss for on-chip components, where energy could easily be leaked into substrate modes, dissipated in ohmic loss within the substrate, or even worse, be radiated in the undesirable direction. So these are some of the issues we need to be aware of. When it comes to millimeter wave ICs, packaging is going to be very, very challenging. And I read out the observation of some expert. As 5G creates a volume demand for ICs at millimeter wave, it creates additional packaging challenges. The package's physical dimension becomes significant fraction of wavelength, which can cause resonance issue. bond wear parasitics, although it need to be taken into account, but at higher frequencies, the impact of inductive parasites can severely impact performance. Thus, bond wears need to be considered as an integral part of the circuit. So at the design phase itself, one need to consider. And it is necessary to think how the package will interact with both the die and the PCB. The key to successful package is co-design of IC and the package in order to optimize the performance of package device rather than that of the chip on its own. It is important to begin by matching the die size with the size of the package, which will keep the bond wires as short as possible. So these are the concerns of some of the industry specialists. Apart from that, as I was talking repeatedly, the millimeter wave will have antenna arrays. So the new package are being developed to combine RF chip and antenna array in the same unit, which is called antenna in package. Idea behind these new integrated antenna schemes is to bring the RF chip closer to the antenna array to boost the signal and minimize the loss in systems. The last component which I will discuss before I conclude is the issues with the ADCs. The power consumption of ADC still dominates the total power consumption in the whole RF chain, and power consumption of ADCs increased with the sampling rate, and at millimeter wave bands, when you are having 500 megahertz bandwidth, you will have to sample at least at gigahertz. So with the ADC and with the ADC resolution. So they have provided this paper has provided some typical values around 500 milliwatt for a single ADC, which is having high resolution and high sampling speed. And if you consider a massive MIMO system with say 256 RF chains, you require 512 ADCs, and the ADC power itself will be as high as 256 watt. This is what people are worried about. Now, there are two approaches. One can employ several high resolution, low speed sub ADCs operating in parallel, but this has the impact on ADC structure may impose error flow on the system performance due to mismatch. What is being now given more attention is the high speed but low resolution ADCs. It decreases both power consumption and hardware cost, but what it increases the signal processing challenges, and particularly when you have PAPR, large variation, and if you are using low resolution ADCs, signal processing challenge increases manifold. So this is in brief a communication person's overview of some of the emerging challenges and opportunities of utilizing millimeter wave in the next generation of wireless systems. And I always believe that challenges create more opportunities for us to solve. And I hope that the faculty colleagues from different universities of India who are attending this FDP, for many of them are working in this field, for them it might have been a repetition. But if some of these challenges can be taken up and solved with your students, and also the students who are specializing in the area of semiconductor and VLSI are given the exposure to the challenges they are going to face when they design these systems targeting wireless communication technologies. This will be very, very beneficial, and it will actually make them industry ready. With this, I conclude my talk, and thanks for your attention.
Thank you, sir.
Thank you, sir, for your nice presentation. And I request participants to please ask questions. You can raise hands, and Ms. Pooja will read all the queries asked in this particular topic.
I request all the participants to please put their queries in the Q&A section.
Gaurav, be there because I'm not a semiconductor person. I may not be able to answer the queries from the device.
Sir, I am here, and Mr. Ashish, they are both of them are also here. So I think they will be able to how to say answer.
Because what I tried to give is a perspective from communication perspective, what is needed in the circuit design.
Yeah, actually, sir, this is required because there are both the angles are there. I mean to say 5G, when we talk about the communication cannot be ignored. Okay, so that's the prime, because for that we are designing the circuits. So that is one of the most essential part, and that is why I requested you to please deliver the talk, because you are one of the best in the country who actually can deliver nitty-gritties of the, you can say, 5G and the RF in the most simplistic manner. So Firoza, can you please start reading the Q&A section?
Sir, till now there is no queries, sir, in the Q&A section. So
Okay.
we are waiting.
Okay. So since there is no query in the Q&A section.
Excuse me, sir?
Pardon? Yeah.
Sir, there is a query. What is the challenge for channel modeling? What is the challenge for channel modeling?
Okay.
Yeah, channel modeling, lot of challenges are there. First of all, why you require channel model? Because the communication system that we develop, that need to be tested before deployment. And a channel model tries to replicate the environment in which try to work in a more fruitful manner by capturing some of the very essential parameters. Now, for example, delay is a major parameter, delay spread, RMS delay spread, then type of heading, then this, as I told, Doppler shift has an impact. So all these things are captured in a channel model, and usually ITU they give some they recommend some channels models for which the system need to be tested. So ITUR models are there, SUI models are there. Recently, a New York University group led by Professor Rappaport, they have done lot of measurement campaigns, and they have come up with a simulator where you create actually the scenarios corresponding to different millimeter wave scenarios, considering the absorption of signal because of the foliage, obstruction by physical objects, and they have done lot of measurement campaign and then come up with the statistical model for that. Now it is very, very important to have a channel model, because whenever we develop the algorithms, particularly when we try to decode the signal, we ask this whether we have the channel state information available with us, or we fully or partially. Recently, we are observing people are trying to use machine learning techniques also in estimating the channel, whereby you can actually have the model trained on some data can be used to predict the channel behavior. It will anticipate in some other environment or some other frequencies. So this type of activities are going on. Channel modeling is very, very important, and because you cannot always deploy a large communication system and find that it is not working. You must have the channel, and testing of systems is done under severe channel conditions, and it is a major task in the industry, and it is done through simulation. Hope I could make it clear.
Thank you, sir. So the next question, any other dielectric material are used for design of waveguides, not like aluminum or copper in RF ASIC design?
Dielectric waveguides are there, and it is a very people have tried designing dielectric like alumina, even the other dielectric silicon itself is used. So the waveguides, these are analyzed. I'm not an expert, as I told, in the RFIC areas, but the waveguide concepts I know these are used on the dielectric material, either alumina type or silicon type material, it is used. Actually, these are high dielectric constant materials. Yeah.
Yes, sir. Please, sir.
These are high dielectric constant materials and confine the waves within themselves. And waveguiding, of course, in the metallic waveguide, the boundary is between metal and dielectric. Here, it is dielectric boundary. And in fact, optical fiber is a dielectric waveguide. It is a cylindrical dielectric waveguide. And you can apply all your EM equations there.
Thank you, sir. So the next question, how 5G help in vehicle-to-vehicle communication?
Oh, this is a big topic. What we are talking of is V2X communication, vehicle to everything communication. This is the target, because people are going for automated vehicle, driverless vehicle, and this, when you have the driverless vehicle, the vehicles must communicate. Now, millimeter wave is being explored. Already, I know that the driverless vehicle or the vehicles capable of sensing pedestrian or other obstacles, these are being developed around 70 gigahertz, which is again in the millimeter wave. Vehicle to X communication is also being tried at lower frequencies around 28 gigahertz. And communication between high-speed vehicle is a particular task in 5G.
Thank you, sir.
Hello.
The next question, how can we decide whether we will use sub 6 gigahertz band or microwave band for a particular application?
See, this frequency allocation and use of frequency bands depends upon many things. First of all, the at the lower microwave frequency bands, the atmospheric absorption and other things are quite less. As you go to the millimeter wave bands, there are certain windows where the atmospheric absorption and the absorption due to water molecule, rainfall, these are less. So first of all, you will have to look for a proper window. As you go higher and higher up, there are certain windows available. Second is the technology availability. As I told, many RF front end particularly, these are dependent on two things. One is the wavelength, another is the uh, technology. Now, today we have a mature technology for the sub 3 gigahertz or even sub 6 gigahertz band, whereas millimeter wave, people are still struggling. Only few circuits actually functioning has been demonstrated, which can be taken to commercial purposes. Although for defense purposes, millimeter wave being used as a long time. But please try to understand, their cost is not the criteria. When you come to commercial communication system, the first thing is that users should be able to buy your equipment. So cost is a major factor. Whereas when it is defense application, you can have very costly system in place because the number of such systems are going to be smaller. It is not in millions. So definitely you need to have a technology that is there, which can give you low cost millimeter wave or microwave systems. And this consideration, then size comes into picture, weight comes into picture, power dissipation comes into picture, how long it can run with a battery. So it is not a single, the battery technology, it is important. The touchscreen technology, it is important to design the entire system. And moreover, most important thing is the spectrum, because spectrum for commercial wireless communication like cellular communication is not available freely. Certain bands which are called ISM bands, which are available for experimentation purposes or operating. But as you go for cellular communication system, the operator has to purchase spectrum, and this depends upon the policies, national policies. For example, just yesterday I read latest that India is possibly going to release the spectrum for auctioning somewhere around 2021. And which portion of the spectrum it will be released, that will depend whether it will create interference with some existing satellite communication system or existing radar system. All these things are to be looked into. So in US, already 28 and 39 gigahertz bands, they have started using. We have not. So which frequency you use is not a straightforward answer. It depends on technology, it depends on environmental factors, it depends on the cost of deployment, and it also depends on the policies, it depends on the environmental clearances.
Thank you, sir. So is 5G with optical fiber is compatible for communication?
Optical fiber is very much there. Even today, from one base station to another base station, the huge amount of traffic is being carried by the optical backbone. So any wireless communication system this is not fully wireless. At the backbone level, we have the optical fiber connecting the base stations and access points and other things. So it is very much there. Apart from that, in 5G, people are also trying to, like IoT type of application, Li-Fi is coming into visible light communication system for short range communication are also being tried. So optical domain is also very much there in the 5G.
Thank you, sir. So the next question, how much path loss tolerable in 5G system?
Path loss, the link budget you mean to say, it depends upon the receiver sensitivity. It depends upon the technology and receiver sensitivity. Present day mobile, we can actually, the receiver can pick up signal as low as minus 80 dB. So around that figure will be there, and accordingly, the distance and other things will be decided. We have a sensitivity of the receiver, how much minimum SNR is needed to run your RF front ends, that decides the distance you can cover and also decide how much power you can transmit without creating, and the path loss exponent of the intervening media. So all this comes into picture. At present, as I know, the mobile phones are able to pick up if as low as minus 80 dBm. But if you go below that, you will hit the what is called the noise floor, because ultimately your signal has to be picked up. Even if you do not give any input to your amplifier will generate noise. And then there will be noises contributed by other system components. So you require a minimum input signal power to be provided to your system, because when you amplify the signal, the amplifier itself adds noise. The exact specification, I do not remember, of the order of minus 80, minus 90, these are standard values. Hello, Firuza? Hello?
Yes, sir. Thank you, sir. Yes, sir.
Hello.
So, sir, no more questions, sir. Almost, sir, we have covered all the questions.
Okay, thank you. Thank you very much. I once again thank Gaurav for providing me this opportunity to deliver this talk and answer to the queries of the participant. I'll be
Thank you.
very happy if the talk becomes beneficial to the participants.
Yeah. Thank you, sir. Yeah. Sir.
Thank you.
Yeah.
So can I disconnect now?
Yes, sir. I think like Gaurav sir will be connecting back. Sir, thank you, sir, on behalf of E&ICT Academy. So yes, sir, you may, so you can stop sharing, and
I have already stopped sharing. I can disconnect. I
yes,
can
sir.
disconnect
Okay.
now.
Yes, sir, you can, sir, disconnect. Thank you, sir. And dear participant, there are few important notification for all of you. announcement for all of you. We request you all to please note that all the participants are requested to please connect through the registered email ID. Every day, all the participants will be receiving an email from WebEx, messenger@WebEx for joining the session. You have to join the session by that link. Please, all of you join the session by the registered email ID because that registered email ID will be used as a marker for marking the attendance. So it is an important announcement for all of you. Please note that you have to register by the registered email ID. You have to join by the registered email ID, and that is the only ID through which we will be marking your attendance on daily basis. Request you please use the YouTube link only for reference. You need to connect this session through the event link because we are not maintaining any attendance in the YouTube link. So all of you have to join the event through that link. Tomorrow we will be having quiz. The quiz timing and all the related informations are already uploaded in the drive. The drive link is already shared with all the participants through email. We request you all to please check the email from E&ICT Academy IIT Guwahati. You will get all the information. The drive link is provided where all the important notifications are given. Tomorrow, the quiz timing will be for 15 minutes. You need to log in as per the time given. There will be 10 questions, 1 marks each question, and you have to complete all the questions within 15 minutes. So, we will break for today's for the first half of today's session. By 2 p.m., we will start the next session. Thank you.
Hello, Firoja.
Yes, sir.
So, have you concluded the talk?
Yes, sir. Ratnajit, sir. Yes, sir. Ended
Yeah.
the session.
Okay, thank you. So thanks all the participants. Thanks all the experts. So I think the next our thing is at 2, right?
Yes, sir. 2 p.m.
Hello?
sir. Yes, sir.
So 2
Sir,
p.m.
2
So because there was a delay, so instead of 2, please bear with us only for today. We will start at 2:15 so that you get at least half an hour to take your lunch. So we begin at 2:15, and I myself will be introducing all the experts to the participants. So I again meet you guys at 2:15. Thank you.
sir?
Hello.
Hello, I am here.
Yes, sir. Sir, shall we start, sir?
Yeah, I think we wait for a couple of more minutes because participants are joining. है ना?
Okay, sure. Thank you, sir.
Yeah. Yeah, shall we start, Roja?
Yes, sir, we can, sir.
Yeah. So, just a moment.
Ashish sir and Aditya sir are connected, sir, already.
I know. So that is why I am just going to introduce them to everybody. So here. Hello. Good afternoon, everybody. Am I audible, Firoja, rightly, right? Hello,
Yes, sir.
am I audible, Firoja? Yeah,
Sir,
okay.
yes, sir.
So, yeah, thank you. Good afternoon, everybody. I take this opportunity to introduce the experts of our program who are going to take you on this RF ASICs, 5G RF ASIC drive for the next 10 days. They are Mr. Ashish Jindal, Dr. Aditya Koti, and Mr. Puneet Mittal. Mr. Ashish Jindal is a senior scientist at DRDO. He has more than 5 years of experience doing RF integral circuit design. He is president board medalist from IIT Roper, and he is part of multiple national conference and their committees. This is a privilege because usually most of the president board mates, as per my experience, they leave India, okay, to pursue career abroad. But Mr. Ashish has, you can say, chosen his path to and you can and to contribute to the society through DRDO. That's an amazing. You can say that's a remarkable thing. Okay, and I really congratulate Mr. Ashish for this particular decision he had taken years. I'm to say in the past. Okay, and he is actually I think that he is the right person for me to give an example now many years to come. The second one is with Dr. Aditya Dalakoti. Dr. Aditya Dalakoti is a senior technical specialist as a Continental Advanced LiDAR Design Solutions under Technical Center in India. He did his BTech in Electrical Engineering from IIT Rupert. Following this, he did his Master's and PhD in Mixed Signal Circuit Design from University of California, Santa Barbara. After that, he has been involved in the research and development division of Continental in both US and India. He has been very active honorary advisor for multiple education organizations such as TechnoReady and VLSI Expert. Dr. Aditya Dalakoti is one of the leading experts in the country in the RF area. I interact both with Dr. Aditya and Dr. To be doctor, I prefer to say to Mr. Ashish Jindal because he is soon he is going to submit his PhD thesis at IIT Delhi as well. With both of them, and they are actually working with IIT Guwahati closely on multiple issues. Couple of projects, whether there is a summer internship with the students or whatever, they are really contributing. Last but not the least, we are having for the today's session Mr. Puneet Mittal. Mr. Puneet Mittal actually is a founder of VLSI Expert Private Limited. He holds BE Electrical and Electronic from COER and a Master's in Communication System from BITS Planning and MBA from Symbiosis Pune. He comes with a rich expertise of 14 years plus experience in embedded system design, semiconductor industry, and has worked with organizations like in VLSI industry like Cadence, Synopsys, Magma, and LSI Logic. In VLSI area, Mr. Puneet's key expertise are static timing analysis, placement and route flow, methodology development with leading industry tools from Synopsys, Cadence, and Mentor. Proficient in handling them, mentoring, project management, and customer engagement. Puneet has been working since last 10 years to bridge the gap between the industry and academia with the help of seminars, workshops, and skill development programs, guest lectures. He is also doing consultancy in education sector from school level to university level in terms of designing curriculum, training faculties, infrastructure building, advanced learning techniques using technology. He has also been instrumental in skill development in VLSI design, VLSI domain for almost a decade through a dedicated online portal. He has created an online VLSI expert group in the semiconductor field through which he is interacting with several students, educational institutes and universities. He is associated with several social professional societies which are in education sector like Youth Career Counseling and Empowerment Bureau and Indo-Canadian Innovation and Skill Development Center. He loves doing career counseling and mentoring to students. before I came in contact with Mr. Puneet, I was working with many other people, but somehow I was not getting the proper satisfaction. Okay, knowledge is one part. Okay, but at the same time, the society, I would say our duties to the society is actually another part, and that is actually, I think, that is the most important part. So when I interacted with these three young guns, I found that their motivation, their attitude, and their entire you can say vision to contribute towards the growth of the country in the area of VLSI, whether that is the standard digital systems or analog or RF, now 5G RF, okay, is way different as compared to many other people. And it is the vision actually which drives the people. Okay. So what I found that although they are quite young as compared to me, but they have really a much higher energy as compared to me as well to take a lot of things, a lot of initiatives in the right direction. So I also, you can say, I agreed to work with them on a, I can say, for specifically the building of the research and the educational environment in the country in the area of VLSI. Okay, and that precisely is our motivation. Our Honorable Prime Minister Shri Narendra Modi ji has said that India must become Atmanirbhar or the self-reliant. Okay, I have been saying this thing to that India must become Atmanirbhar and the self-reliant since last many years. And I'm very glad that when the day when our Honorable Prime Minister also narrated the same words, our Prime Minister can only you can say lead us the way. It is we who will have to walk through the path. Many of you would have seen the movie Matrix, which came in year 2000, in which Keanu Reeves actually and Lawrence Fishburne were the actors. And there was a character of the you can say the Morpheus and the Neo, and Morpheus very well says that I can show you the door and you have to walk through this. So I think that and if I have to just say in a lighter and you can say note that our Prime Minister exactly has said the same thing. Okay, but how we have to cross the door, that actually is one of the biggest hurdle. Without adequate knowledge, actually we cannot do that. Even I cannot do that. Okay, before this particular you can say section, I was taking part in one of the panel discussions in a quantum computing course which is being hosted by MNITJ Jaipur. In that course particularly, the idea was that how to do this, and Microsoft actually is doing all this, providing all kind of support to that. Okay, so we want the quantum computer to at our end, okay, and we want our expert to be at our end. But how these two things will happen? And in 5 years, we want to have the quantum computer at our end. At the same time, we want the trained manpower of the expert workforce to be there with us. But how this will happen? If we do not play well, okay, and if we do not play in the right direction, okay, we will lose another war. The way we have lost the war of microprocessors. Now we are saying build microprocessor. Friends, we are 30 years behind now. And we are totally depending on the foreign technology, whether that is a RISC-V architecture, whether it is Spark 8 architecture or so. I would say we are just copying the instruction sets. What else we are doing? What are the innovations we are driving? Do we have our own indigenous instruction set, okay, processor, which we can say, hey, this is mine, completely designed in the India. And this is bug free. No scope for the hardware trojans also. We don't have. So unless we have the proper workforce, we cannot achieve the aim. And that is why specifically our endeavor is to, you can say, build an excellent ecosystem. It doesn't matter which part of the country you are, which engineering college you are. If you are really interested, you can always get back to me. And you will always find me by your side for that. And not only me, you will always find Dr. Ali Talakoti, Mr. Ashish Jindal, and Mr. Puneet Mithal by your side. So I will not take much time. And I just say, this is the beginning of the endeavor, or this is the second beginning of the endeavor, I prefer to say, because just 1 month before, all these three of my colleagues, I can say now, they have delivered a 1 month complete skill development program to Assam Science and Technical University students. 316 students attended that particular program. And not only there, they have taught them the nitty-gritties of the digital design, Spice, Magic, using RISC-V architecture and how to proceed with that. But also they are doing they are actually handholding them to complete their project so the right knowledge can actually be imparted. So with this, I very much welcome Mr. Ashish Jindal from SSPL New Delhi, Dr. Aditya Dalakoti from TechnoReady, and Mr. Puneet Mittal from VLSI Expert to deliver course in this particular FDP and interact with all the faculty members, students as much as they can, so that we can deliver the right piece of information in the best possible manner to make Atmanirbhar Bharat idea become viable. Thank you. So now onwards, I pass the baton to all these three young guns. And if there is any problem, you can always get back to me. And before we begin formally, I request Mr. Aditya to say something on this, Dr. Aditya to say something on this, and Mr. Ashish Jindal and Mr. Puneet Mittal. So I begin with Mr. Puneet Mittal to say something on this particular program, and then I will take all of your leave to address other of my academic duties today. Mr. Puneet Mittal.
Thanks a lot, sir. Am I audible?
Yeah, yeah.
Okay. So, nice introduction, sir. So it's like I'm not that that person like the way you have explained, but it's your I would say in Hindi, so your badapan, like you were just introducing us in this particular way. We are going to do our best, and yeah, one thing you said rightly, like okay, it's something like I want to bridge the gap between the academy and the industry. So after serving almost like 14 years in the academy, in the industry, I figure out like okay, there are a lot of things, a lot of places we have to work. So the reason I quit my job, high-paying job, and I'm just doing all this particular part, that is one of the reason. Like okay, someone has to step out from the industrial side, and they have to do these things, because if everyone is going to run behind the money, then things are not going to happen in the right way. So yeah, that's all from my side regarding this particular program. Most of the time Ashish is expert in the 5G side, so he is going to just interact with all of the attendees. And yeah, Aditya is going to be like the second person. But yes, I will just try my best, like okay, from the VLSI point of view, what best I can deliver when it comes to like 5G and the VLSI and the ASIC side. That's all from my side, sir. Thanks a lot.
Thank you, Mr. Puneet. May I request Mr. Ashish Jindal to say a few words in the beginning of the program?
Thank you. I would like to say thank you for your appreciation that you gave me. About this course, we will try our level best so that you guys can get a good idea what is all 5G is all about, and more importantly, how the system works, how the components that is required to design a 5G system, how you can design it. Okay, so we will give you a good feel for that, so that from now on, if you want to pursue career in this RF analog design domain, so you will be getting a good, I will say, a good kickstart with this workshop. So with this, I will like to say thanks again to Gaurav sir for giving us the opportunity so that we can also contribute towards the betterment of India. Thank you, sir.
Thank you, Mr. Ashish. And now I request Dr. Aditya Dalakoti to say few words before beginning of the program, and take the pattern in his hand to proceed further.
Thank you, sir. Thank you for those really, really kind words. And we will make sure we live up to your expectations on this. And the E&ICT Academy and IIT Guwahati, and especially you, sir, have given us like excellent opportunities, with this being one of them. And yes, we will make sure that we never let you down on these opportunities. With respect to this program, our motivation has always been to provide the students or whoever is trying to learn the aspect of learning from the practical side. So if you have to design something, what should you do? There we have observed from the industry perspective that students who come into the industry, they know a lot of theory, they know a lot of big words. But when it comes to actual implementation of those big words and actually implementing the things taught in the theory, it becomes really hard for them, and it is challenging for the industry to teach them in the beginning and to bring them up to that scale. So everything we try to do is in that perspective, and we really thank you, sir, for providing us this opportunity to make it our dream to be actually true here. Thank you, sir. And yes, we will carry this forward, sir. Really appreciated with Firoza ma'am's help. And yeah, thank you, sir.
Yeah, in fact, I just also appreciate, because moving, I just say, Miss Firoza Haq is literally has become our backbone, and one of the most humble and, you can say, dedicated human being I have seen after coming to IIT Guwahati. So thanks a lot, Firoza, for your all support, and your support will always be continuing with us. I hope so, and I have firm belief on that. Thank you, and thanks all the participants. Thanks all the, you can say, our proctor coordinators who actually worked day and night specifically to, you can say, uh, so that we can have 700 plus participants there with us in this particular course. And so thanks a lot to all of them. I really have no words, okay, for their hard work which they have put. And I'm to say, I personally, you can take it my personal compliment and my personal thanks as well towards the effort you have put to this course. And with this, I take all of your leave, and I thank all the participants and wish them a very good luck, and say happy learning, stay safe, stay healthy. And if there is any problem, always get back to us. We are there to help you. Thank you. And I am signing off for the day. Thank you. Bye-bye.
Thank you, sir. Firoza ma'am, I will start today's presentation first. So if you could give me sharing rights, that would be helpful.
Yes, sir. So it has been shared with you. So please
Okay.
check once.
Yes, I think I can share. Thank you.
Yeah. Thank you, sir.
So ma'am, can you confirm if you're able to see my screen and there is nothing blocking it?
Yes, Aditya, you can start. It's like, I think it's okay. Visible.
Okay, perfect. So hello everyone. Good afternoon. And I know it has been a long day. So the idea behind today's session by Ashish and me is to give you an overview of basically what is to come in the next 9 days, give you some introduction into what this 5G is about, so that when you come in nice and fresh on the next day, you're able to better appreciate the course. We will continue with this introduction a little bit tomorrow morning as well, because today it has already been a long day, and we will then carry it forward with specific courses structure as we will explain in today's session. So with respect to 5G, there has been a lot of buzz in the industry, and our esteemed panelists today from Siemens, from academia, from SCL, everyone explained different aspects of it. And everyone presented their point of view, and you could realize from their point of view that there are a lot of challenges in front of us. And those challenges are in everything. Those challenges are from communication side perspective, to design proper algorithms, to design proper architectures from communication perspective. Those challenges are from system perspective as well. If there are so many ways, so many applications where 5G needs to cater, then what do we do? So how do we solve that issue? So from in that regard, what's going on is bunch of those challenges at the end of the day boil down to how do you actually design your ASIC? So ASIC is the fundamental core, uh, knitting it all together. ASIC decides where and how or which challenge you can meet. So all the specifications boil down to how an ASIC is implemented for a 5G RF application, and this is generally true for other aspects of designs as well. So when we thought of the RF and 5G domain, we thought we should present this workshop from the basics of ASIC side. As we have mentioned in the fundamental requirements for this course would require just fundamental knowledge of analog design and some circuit theory. We will try to build up your RF circuit design knowledge from that basic aspect, and we will carry it forward from there. So, sorry, in that regard, yes, sorry, give me just a moment. Let me fix one thing at my end. Yeah, sorry. Yes, sorry about that. So let's start with this overview, okay? And what I will do is I will try to take the questions towards the end because today's session from my end is quite short, and we are actually running quite delayed. And since it's the first day, it's quite expected. And then before Ashish gives his session, we'll try to take questions in the middle and then carry it forward from there. So with respect to introduction to 5G, and you know my name is Aditya Dalakoti. Now, a lot of panelists today gave you a bunch of application space for 5G already. So this is just refresher of the same thing. And from the refresher point of view, the general communication application space as it is building up with the advent of 5G and 4G progressing and developing more and more, and 5G going into different application spaces, you can divide it up into roughly, and these overlap with each other, obviously, as you can see from the diagram, but roughly you can demarcate them into 3 application spaces: enhancement of mobile broadband, massive machine type communication, and ultra reliable low latency communication. So our esteemed panelists already went into the details for these. So the panelist from Siemens, he told you guys that you would need to design specific systems for each of the applications. And even in each of the application, if you go into it, so for example, even inside an industry, so there is machine to machine communication in the industry. So you will have to design systems which are specific to that industry, that layout, that architecture of actually the building even. So now if we take a step back, from and we think we have these application spaces, I'll come back to what a little bit more explanation of these. But what is the fundamental component which has to be redesigned or which has to be reused? So redesigned and reused are 2 terms here. So the fundamental component which will lead to the development of that system, one of the fundamental component is an ASIC, so RF ASIC. So we need to understand when do we need to redesign that, and when do we need to reuse it, and actually when do we need to design it. So some of these things actually do not exist in the market at all. So coming to what exists and what does not exist, let's look at the application perspective. Okay, so what is enhancement of mobile broadband? So mobile broadband we all have right now, right? So some of you might be connected to this program through your mobile broadband. So we consume GBs and GBs of data. So my Tata Sky fiber optic link gives me 1 terabyte of data at 100 Mbps of speed per month. And I'm consuming like hundreds of GB in a day sometimes. So basically the data requirement is going to go up and as we proceed. Now currently that those requirements, high speed requirements, are met by fiber optic links. With the advent of things like virtual reality, video monitoring, and ultra HD video streaming, real-time gaming, all of these things will need to be done in the mobile broadband space as well. So an example of this can be, suppose you are, let's take a couple of examples. So suppose there is a World Cup or an IPL match going to happen in Dubai right now, and we cannot go there. Why? Because of the Corona thing. Now, can we actually get a real-time live experience of watching that game? Yes. If the latency is low enough coming for the signal coming from Dubai to here, and if the speed, the effective speed is high enough, then we can watch it as if we are sitting there. We just put a headset, a virtual reality headset in front of our eyes, and we will be observing it as if it is happening in front of us. So that is one of the challenges with respect to speed. There are other challenges with respect to system design and stuff, but understanding from the speed, the latency point of view, that's how the enhancement of mobile broadband would work. Then the next thing which comes to the picture is the next thing which comes to the picture is the massive machine type communication. So what massive machine type communication comes to is there will be almost infinite number of devices which will have to be connected to each other. So you can understand it from the perspective of IoT basically. So what is IoT? IoT is everything in your home, from your mobile phones to your even your toaster oven, to your fridges, to your smartwatches, to everything, to your smart bulbs. Everything has to be connected, and everyone is trying to connect them in real time. Plus, everyone is trying to never recharge them. So the smartwatch you wear, people are more expected to never run out of battery. So there is the other aspect of 5G where people want a lot of communication happening between a lot of devices, which can be sporadic in nature. And people expect the devices to acknowledge their communication instantly. And even though they have so many devices connected, they still want the acknowledgement to be instantaneously. So you need to understand it from the perspective of the connection density here. The connection density is going really up. So you have too many connections in a given small area. So that is the challenge which this machine type communication brings up. Then there is a side of 5G which will bring up is ultra reliable low latency communication. So what this ultra reliable low latency communication does is, suppose there is going to be a surgery in a remote place, and they have all the equipments available with them to do the surgery, but they do not have the expertise of the doctor who is capable enough to do that surgery. Now, how do you do that? So if the latency again from the doctor's office to the actual place where surgery is supposed to happen is low enough, then the doctor can just do it in the real time. So you need to understand how low that latency has to be so that the doctor is able to make precise cuts, right? So from that perspective, there is ultra reliable and low latency communication space. So all of this gives us a communication space where 5G is building up to. Now, as I mentioned already before, there is overlap between these communication spaces, but as the panelists have already pointed out, we largely going into 5G we need to design systems which cater to the application. So it will be very hard to design something which solves all our communication needs, because somewhere we need to save battery, somewhere we need to have really fast communication, somewhere we need to have a lot of data going through. So depending on the use case, we'll need to design the system. Now, putting these things I just said in perspective, I just wanted to give you a brief overview before we dive into a lot of these things. So we know, first of all, what is an RF communication? So in an RF communication, there is a transmitter and a receiver. So for example, right now, I am the transmitter and everyone listening to me are receivers, and vice versa as well if there is a communication. So I am transmitting a piece of information which you guys are receiving. So if this information is actually going through the electromagnetic spectrum, through RF waves. So either the optical fiber one is different, but if it is going through the air, for example, so there is a carrier, and that carrier is modulated in some form or the other. So depending on the application space, it can be digital, FM, or AM modulation, and then you have a modulated signal, and that modulated signal is passed through the channel. Receiver gets it, and that receives signal, demodulates it, gets the carrier out of it, and if you get the carrier out of it, you have the effective base signal. Now, leaving all these nitty-gritties of RF communication apart, what you need to understand is there is a carrier in there, first of all. So this carrier is what people talk in terms of frequency. So first of all, this is the center frequency. So when someone says this is a sub 6 gigahertz system, so for example, 5 gigahertz system, so that 5 gigahertz is this carrier frequency. Now, as this carrier frequency scales up, as it goes into, as a panelist pointed out, as it goes into the 24 gigahertz band or 28 gigahertz bands, it brings up a lot of design challenges which are unique, which have never been tackled. So from ASIC perspective, our job is to actually try to make circuits which actually are able to work on those frequency domains. So can we actually, the questions which are coming to the research community at this point are, can we actually make an ASIC at 28 gigahertz in CMOS technology or SiGe technology, which actually has good reception or which acts like a good receiver or has enough power from the transmitter side so that it is able to travel long distance? So these are questions which actually no one has the answers to right now. So this is just an overview of from the RF communication perspective, that there is a carrier and then you put signals on top of it, and the signal you put on top of it has some frequency of its own. So that frequency which it has on its own is called the signal bandwidth. So a lot of times we'll talk about what is the bandwidth of the signal. So typically in the LTE spectrum around 1.8 gigahertz, the bandwidth of a channel is around 10 megahertz on one side. So that's the bandwidth. Going into the 5G in the 25 gigahertz or 28 gigahertz space, people are talking about bandwidths in the range of hundreds of megahertz. So that is scaling up. So the more the bandwidth you have, the more data you can communicate. So why people move up the scale and frequency? To get more bandwidth. And there are other benefits like latency and so on and so forth, which we will explain as we go along with the course. Now, coming to things which I've already mentioned in the previous slide. What is 5G? Basically, higher frequency spectrum for communication channel. So these are words put in very simple terms. So what are we trying to do? We are trying to do communication at higher frequency. Why are we trying to do? We want more bandwidth. We want lower latency. And what does it lead to? It leads to circuits which are harder and harder to make. Why? Higher frequency is equivalent to small wavelength, and from the digital signal processing perspective, it becomes a nightmare because your simply put, the signals will reflect, come back, and you have to take they are wavelength apart. So there are issues in the DSP domain, and higher frequency also means that your loss is higher and higher. So I'll show you a loss spectrum, and a lot of people are aware with freeze equation, and Dr. Ratnajit Bhattacharya also pointed out the freeze equation. With the more higher the frequency we go, we have higher and higher losses. So it becomes very, very, very hard to make these ASICs. So we are now coming to the fact that what are the design challenges from the ASIC perspective. Now, going into a little bit, just an overview, I'll give you the journey from 1G to 4G. So 1G was a 2.4 kilobit per second system, which was voice based, and it just needed analog based protocols. Then we said, let's step it up a bit, make it 64 kilobit per second. It was designed for voice, but the standards like GSM and CDMA were put into it. It improved our coverage and capacity. Then we jumped to 3G. A lot of you would be aware of there is still 3G networks at different places. It is designed for text, and some multimedia applications can go through the network. It was effectively the first mobile broadband which we saw. Then the 4G came into the picture, which we are currently using for mobile communication largely. And this increased the communication speeds to 100 kilobit per second, and it was designed primarily for data purposes. So we are doing massive data streaming on mobiles right now. And there were LTE-based IP protocols which were implemented, and this is the true mobile broadband which we are using today. Now, coming to a diagram which one of the panelists already showed, I just wanted to add a few more things into that diagram. So someone already showed you the specifications trade-off octagon, and I don't want to spend too much time on it because of that. But just to overview what this trade-off octagon says is there you want to achieve higher and higher area traffic capacity, peak data rate, user experience data rate, spectrum efficiency, mobility, latency, connections of density, devices per square kilometer, and network energy efficiency. Now, trying to achieve this, the question is, what can we achieve actually? There might be a case where we can achieve a lot of really low latency of a millisecond, but we cannot really achieve a very high area traffic capacity, or we cannot achieve a very high network energy efficiency. Similarly, we can probably achieve a lot of high connection density, but we cannot achieve very high network energy efficiency. So things like those. Okay, so this is our trade-off octagon, which people talk about in terms of our communication space. So to put it in perspective, today in 4G, we work in this yellow marked region. So our peak data, user experience data rates are about 10 megabit per second. Peak data rates are 1 gigabit per second. We can have about 10 to the power 5 devices per square kilometer, and all the other things mentioned over here. Now, yes, this diagram was also shown by panelists before, but shifting it to the end. Now, I told you 3 application spaces. Now, these 3 application spaces were, first one was enhancement mobile broadband. So if you're trying to have enhanced mobile broadband capacity, you would ideally like to have higher peak data rate. You would want to have better user experience data rate. You want higher spectrum efficiency, network energy efficiency. You would want to be sitting on a plane and still get signals, so higher mobility, and also area traffic capacity. So if there is also a lot of people in a given area, you still want to be able to have higher data rates. But connection per density is not that critical, and even latency is not that critical. But going into the massive machine type communications, the most critical thing, as you can see from this diagram, is this connection density per square kilometer. So devices per square kilometer really needs to be high. The rest of the terms can be low. So why they can be low? So for, say, for IoT like things, you can have small lower data rate. You can have user experience data rate can be low, but you want very, very, very high connection density per square kilometer. So that is from the perspective of massive machine type communication. Then from the perspective of ultra reliable and low latency communication, what do you want? You want very, very low latency and very, very high mobility. So these two terms are extremely important for ultra reliable and low latency communication. And the rest of them you can have on smaller amounts basically. So as I pointed out before also, these three design application spaces, enhanced mobile broadband, massive machine type communication, and ultra reliable and low latency communication have trade-offs from the design perspective. And where do these trade-offs lead to? These trade-offs lead to our ASIC. From ASIC perspective, these trade-offs lead to different designs. So you might, for ultra reliable and low latency communication, you would design in some other way, some other ASIC. For massive machine type communication, you would want some other ASIC. And even then what system builds on top of it would be different based on that ASIC. So the core of all of it is the ASIC which is there. So that's the perspective. Going forward, we'll teach you the basic, how you'll design those ASIC subcomponents. Now, just to put it in another perspective, the same thing actually. So the three key aspects: capacity, latency, and coverage. So going from inside to outside, we have different communication bands. So we have low band of sub 1 gigahertz. This is all 5G communication space. To put it for you guys to understand, this is all 5G communication space, but different circles have different capacity, coverage, and latency. So for low latency, moderate capacity, and high coverage, you want low bands. You want so the bands like sub 1 gigahertz, you can achieve very high coverage, but decent latency. But as you scale the frequency up, so high bands like 24 to 40 gigahertz, you can achieve really, really low latency, ultra low latency, very low coverage, and very high capacity. So basically the idea is to where do we sit in this? So based on where do we sit, based on our application, we decide which center frequency we want, and based on the application space, we decide what bandwidth we want. And based on those two specifications, then we decide, okay, how do we will look into the link budget again in tomorrow's session. But we decide now, what can we actually, how far can we communicate? What is the output power from the receiver, and what is the input output power from the transmitter, and what is the input sensitivity of the receiver, and which technology can we achieve them at? So those, we'll try to understand those trade-offs, and based on those trade-offs, then we will try to see how does the ASIC subcomponents get developed from that. So from the 5G hardware perspective, there are three things which are extremely important from people trying to learn this. So there is an ASIC perspective, there is a system perspective, and there is a software modeling, open source tool perspective. So in this program, what we did was, even though this is an ASIC development program, but we wanted to give a perspective that how does that ASIC sit in the overall picture? How do we actually model it enough from open source here, because this is open to all India program, so we wanted an open source tool to do it. So how do we model that ASIC, and how does that modeling sit on from the system perspective, so that we are able to get the full picture of the ASIC 5G ASIC hardware. So that was our motivation behind setting up this. So from the other side of the coin, we wanted to show you a problem. The problem is, how do you design 5G ASICs? Now we'll try to, this is a big problem. We'll try to break it down into smaller parts. The smaller parts being smaller subcomponents. We'll try to show you the design aspect of those subcomponents, and keeping in mind the software part and the system part as well. So just so we will come back to this at the ASIC level thing tomorrow again, but just from the system perspective, a very top level overview. There is some signal source there, and Dr. Ratnajit Bhattacharya already showed multiple iterations of this diagram from architecture and communication level, how those diagrams or how do those implementations vary. But from a very ASIC level perspective, you have phase and amplitude modulation of a signal, and that goes into a power amplifier, that goes into an antenna, and a series of those antennas create something called a beam. We'll get into this a little more detail tomorrow. That beam reaches a receiver antenna, that goes into an LNA, that gets demodulated, and we get our signal. So from ASIC perspective, what is important is these components design. So power amplifier, LNA, and then how those power amplifiers, LNA, are connected to the other systems. So how do we match a power amplifier to an antenna or to a transmission line connecting to an antenna? How do we filter the baseband of the signal? How do we filter uh, different frequency bands in the carrier signal? So all those things, all those specific things, how are they actually implemented from the ASIC perspective? How do we actually design them from components, from ASIC components? That is the perspective we want to give you through this program. So that will be the based on the series of next lectures, that will be the perspective which will be provided with hands-on design experience from an open source tool. So with respect to the course structure, Ashish will go into this in more detail. But we first today's session and tomorrow's early session is 5G general introduction. Then there is MIMO introduction. Then we'll go into basics of RF, LNA, power amplifiers, system overview, foundry PDK development overview. With all of this, with hands-on design experience as much as possible. So that is the general overview for this course. I tried to keep it short because it has been a long day. I put few slides for today for tomorrow. Just I did not want to overburden today. And I would now like to answer any questions. Q&A, let me check. Any question? Let me see. Please. Okay, Soham 77 gigahertz automotive frequency, that is a radar kind of application. So radars have other needs with respect to how far the signal has to travel and how fast the signal has to travel. That boils down to automotive specifications for the radar. So that is something from automotive perspective. Basically, that comes from the automotive requirements of, and that is a radar. That is not your traditional communication interface. And we will give you a layout perspective, Sumit. We'll tell you what is the issues of RF layouts. But in this course, we cannot do an actual layout from time limitations perspective, but we will teach you what will be the issues with respect to different layouts of different structures. From RF perspective, obviously, not from digital design perspective. This will be all from RF issues perspective. Okay, so let me then stop sharing. And Firoza ma'am, if you could give Ashish the rights to share, that would be nice.
Yeah, sure, sir.
Sumit, we will, due to limitations, we were not diving into VCO in this session. Ashish, go ahead, please.
Am I audible?
Yes, sir. You're audible.
Okay. Oh, so long day. So I'll try to keep it as short as possible. So my today's agenda. what we all are gonna do in the next 9 days. So before that, I was listening to all the I will say a very informative from since morning, starting from the director SCL Chandigarh, then a expert from the Siemens company, then Dr. Ratnajit Bhattacharya ji from IIT Guwahati. Everyone, even then Aditya Dalapuri has given you, I think, a very good brief about what is 5G, what all aspects of 5G is there, what all I would say, I think how all the fields, you can say communication, design, digital, everything, how they are contributing towards the 5G. This course, I would say, is more focused towards the RF analog design. Okay, so you will get usually what in India prevails is the students go for digital design more. Okay, so you will get a good results in digital, while when you are doing analog circuits design, many times you will not get the results, and you will get frustrated that why are you not getting results, even your all simulations are correct. Okay, so that's what's the issues that comes with analog design. Okay, so it is not digital, it is not 0 1, it can be anything between 0 and 1. So with this, I would I have just added one. I thought you all guys must know what is basically RF analog design is all about. So assuming you all are a analog designer, okay, so I would like to ask you, okay, so I would request you to keep answer in the chat box. Okay, so my question is very simple. I would like, assuming, okay, so don't forget the term, assuming you are an analog designer, can you this? What is it is equal to? Okay, so I'm waiting for if somebody can give some innovative answer. Otherwise, it will be very trivial. Okay. Okay, so Ravi Kumar has given the answer of 3.6 or 0 to 4. Okay, good. Ravi, any other answer from anybody? Who is who? 4 minus the losses 4.0. Okay, we are getting more many answers. So I would say if mathematics guy, this would be 4. Okay, it doesn't have anything to think about. Okay, so it is obviously 4. But once you are a designer, analog designer specifically, it cannot be, it can never be equal to 4. It can never go as close as possible to 4. You can you can go to many levels of 9, or maybe on a higher side you can say like this, you can go from anywhere, but not equal to 4. That's what all RF analog is all about. That is about the range, basically the specification. Just before this, Aditya, I've already told you that, okay, we have a octa gain trade-off. Basically, the word is trade-off. And any design you are doing, there will be some trade-offs. Okay, so you cannot achieve everything. You cannot achieve. So that's why you need specifications for any component, anything that you are, whether it is a simple passive filter, or whether it is a switch, LNA, anything that you are designing, you will be requiring, you will, as a designer, you first always ask for specification. Specification is not just the electrical specification. It includes the mechanical specification, form factors also, size, That is the most important thing when you are dealing with the RF domain. Crucial part, because everything that you are designing, even a simple line, if you have a resistor and an inductor and you want to connect a line, this line also matters. You cannot just, like you used to do in your lab at lower frequency levels, you connecting an inductor to resistor, use a wire that curves like this. But when you are dealing with a high frequency, you cannot do such stuff. Okay, so everything requires specification, cost, efficiency, any designs. So, like if you are making something for the defense, okay, so in that cost does not matter a lot. It is not relevant, but yes, cost can afford to have a high cost system, but efficiency should not be decreased. Efficiency should be as high as possible. It should performance of that thing should be very high. While if you are making the same thing for the purpose to see whether the cost is not too high, because you have to sell it. So cost cannot be high. Obviously, it will lead to the performance degradation. As a designer, you cannot only focus on the, I would say, the electrical specification only. You have to see all the trade-offs, all the things, and you cannot be definite with your things. Okay, so you always need latitudes with your specification. If somebody is saying that I want a, let's say, gain of 10 dB, so this is not just possible. Let us take an example. You might be using a broadband with 100 GB speed, maybe. Okay, 100 GB speed you are getting, but it cannot be 100 GB constant. You never get 100 GB constant data from the provider. It will always vary, and this variation will depend on the channel losses. It might possible that at one time it might be raining. It might be raining someday. It might be humid conditions out there. So that will change the losses. Okay, the channel path, or maybe where the providers the base station and from where the signal they are transmitting, what is the situation there. It might possible some of the component is not working well, so he cannot provide you 100 GB all the time. So he always say like this, minimum this much speed will be there. Okay, so that is what is you say this thing you always remember for, as if you are working as an analog designer. Okay, so this, and we are going to do in upcoming next 9 days. This thing I will say that anything we cannot achieve to a specific number. We always wanted a specification. Okay, whether it is minimum to some quantity, max than some quantity, or maybe some range. Okay, so for any specification, it should be like this only. It cannot be exact number. Okay, so that's basically what is all analog designer. So you should get a feel. Okay, so you don't think as a digital. Somebody is saying the LED bulb will glow, or whether it will not glow. Okay, so that means 0 or 1. But in analog, we intensity it is glowing. So that's what is the difference between analog and digital. Okay, so that makes it more complex. But yes, we'll try to teach you it in a very simple way, and we'll try to give you insight as much as possible. Obviously, I would also like to say this thing that I have tried not to keep many equations, but yes, some equations you require, but don't worry, you don't have to mark those equations. You just have to understand this. Yes, these are the equations that are used to do this design or do this thing. To solve those equations, we have a tool. That doesn't mean everything is to be left for the tool, because the theory is what plays, because sometimes tool might give you wrong answers. So you should be able to judge, yes, oh, okay, so we are not getting what is desired. So for that you need theory. Okay, so that's why we will try to start from the basic of the RF, that is as basic as like what is S parameter, how we defined it, how we calculate, like how we can calculate S parameter, then as like how I design, how LN is designed. So we'll try to give you a overall picture, so that so because we have a, like, I think we have a very large crowd with different experience, so we'll try to like give to manage to give information for all. So okay, so it helps all of you in that regard. Okay, so I think one of the question has, while designing inductor design is a major issue area, how do we? So I would say that is basically I will say that is something specific you are asking. Okay, I will say this workshop is mainly all about is how to design LNA. Okay, so inductor design is itself a topic. Okay, so it can become a topic of for a workshop alone. Okay, so but I would suggest I will try to introduce some things. Okay, I'll give you some alternative of LNA design, so that the use of inductor can be reduced. Okay, so you can think in that sense, so that you don't have to rely much on inductor. Okay, so that's how you can I will say trade-offs between design. That's what we are like we are learning from since morning. In analog RF, in the current world, anywhere, if you are using a wireless communication, that is done by a transmitter receiver module. And anywhere, if you see a signal is traveling without any media, that is traveling through air, that means it is basically it is a wireless communication. And if forget about everything, you must all of you have a dish TV in dish antenna be fitted on your terrace somewhere. So you will just see there will be a little a cylindrical shaped thing in front of that dish antenna. That thing is basically what? That is receiver. And inside that, what is there? Mixer, PLL, LNA, everything is there only. That all is basically analog RF design. Okay. So many more, even like and the signal, if you are doing a wireless communication, the signal cannot be transmitted in digital form. It can only be transmitted in analog form. So to transmit an analog signal, basically, I can say, so you always transmit a carrier frequency. Okay, my drawing is not that good. I'll design it again. Okay, so you always transmit a carrier frequency signal. This signal is always transmitted. Only what is dependent is initially we used to do analog modulation, but right now what we are doing is digital modulation. But that digital modulation does not make this signal digital. It only changes the frequency or phase or maybe amplitude of this signal. But at the end, only the analog signal will be transmitted. So to handle this analog signal, you will be requiring analog circuitry. So in current world, RF analog design has I will say a major role. It has a very high significance. Okay, so you can say any wireless communication or any wireless system if you have, it will be transmitting a carrier signal with along with some message, and it is basically a analog RF analog design. Okay, and with the 5G, you can say from RF we are moving towards the millimeter. Okay, so basically in RF domain we are moving from microwave to millimeter wave. Okay, so we are even going higher and higher frequencies. So this analog design is is of much relevance in today's world. I hope this answers the Vijaya questions. From today's session, I just make this thing so that you guys got to know what are the different areas which helps the RF design. Basically, first of all, we have communication theory. Obviously, we need to know which modulation, how we have to use the channel to increase to efficiently handles the our users random signal. Obviously, the noise, if you have how to manage that with the statistics and probability. Transceiver architecture, obviously, if you want to transmit any signal, you need a transmitter and receiver module. So what is the architecture of that? The component that if you want to design this architecture, all the components are designed in IC designs. So you need a CAD tool for that. Obviously, some wireless standards are there, signal propagation, and the microwave theory that will be required to use all in all these things. Okay, and designing a transceiver architecture or maybe a wireless standards also. So our main focus in this workshop will be in this domain only. Okay, so these three we will target more. CAD tool, like for analog design, tools are quite expensive, but what we have tried, we have found an open source tool. Since Aditya has already told, this workshop is open to all India platforms, so we cannot have such high EDA tool licenses. So we have structured our course so that it can be done on an open source tool, but like a total design flow that can be done. So I will say it help you a lot to start, or maybe even if you want to do a good design in RF domain. Okay, so coming back to the schedule. Okay, so I discussed this on the Saturday also, but just to give the overview, what we are gonna do in the coming 9 days. So first of all, starting from tomorrow, we'll give you an overview of 5G network along with what is MIMO, basically multiple input, multiple output antennas, and what is the link budget that Aditya already showed you how a link is budgeted, and then from that how the specification of PA, LNAs and all are derived. Okay. Then in the second half of the tomorrow session, I will introduce the Scikit RF tool. Will give you some 2-3 tutorials we have, so that you will get acknowledged or get acquainted with the tool, and we will have you get to know some commands or something, so that in coming days when we use it, so you will be able to affiliate better and will understand better. So for that purpose, we kept the second half of tomorrow's day for the introduction of Scikit RF tool. Following that, we will have a quiz, that is day 1 quiz, that will contain question from today's and the tomorrow's session. And after that, on day 3, we'll start with the RF basic. That includes the transmission line, 2-port network, S parameter, and probably we will do one design. Okay, so that will most probably be of combiner, and we will see how we can implement it in tool, and I will try to take it to the layout level. Okay, so so that you will have a feel that how and what are the issues that we can face in layouts, and we can like somehow we can manage that thing here in the tool. Okay, so after that on day 4 we'll give that full day for the filter design, that will start from the filter theory, and will design all low pass, high pass, band pass, band stop filters. After that, again, in high frequencies, designing using lump component is not a good solution. So we'll try to design it using a microstrip line, and I'll tell you how to design a filter using a microstrip lines, and again we'll try to implement that in tool also. And again, following that, we will have a quiz 2 that will be on day 4. And at the end of this week, on day 5, we will be having a session from Puneet, that is an expert from VLSI Experts. So he'll give you an overview, or rather insights about what are the issues that we face while doing the layouts, and what are the packaging issues, testing, PDK development. That is also a part of RF design. Basically, if you are fabricating something, you need models of those fabricated elements, whether it is an active device, or maybe active, or maybe MMIC's inductor, or maybe capacitor. So what are what are the process of doing for the PDK development? On the next week, starting with so that will be, I think, day 6. So on that day we will start with a full day we'll give for a matching network. So in RF domain, any design require a matching. That is, I think, the most important part. So if anyone knows much about the matching networks, he or she can be a very good designer. He can. So so that's why I am trying to I will give a full day for that, so that you all guys get a good hands-on experience or two on the matching network. So we'll try to implement some matching networks and in the tool also. And again, on day 6 we will have a quiz 3. Coming on the day 7, we will start with the amplifier basics, and what are the stability circle, gain circle, what are the classes of amplifier. Okay, so coming for the power amplifier, how to design a power amplifier, what is load pull, everything we will discuss. So that will be mostly a theory part. On that day, there might not be any tool implementation. And again, we'll have a quiz 4 on that day. That is, quiz 4 will be on day 7. Till that, on day 8, the whole day will be dedicated to the amplifier design using tool. We'll try to give you the full process. Okay, so obviously designing is not like you can do in one day, but yes, I will give you a flow. If you are designing on your own, so you know how to go about designing a power amplifier. Okay, so that how you will design it. So obviously it will take time to design when you are designing, but still, because I have already designed one amplifier, so I'll give you how to tackle those problems, what problems came, how to achieve specification of a power amplifier. Okay, so what are the steps so that you can achieve those specifications. Then what all issues that you have to take care, so that you make sure that your design works and it runs well, it performs well when you actually implement it. Okay, so what issues you have to take care for that. Then on day 9, again on it we will have quiz 5. So I think that will be your last quiz. After that, on day 9, the complete day will be on starting from the basic, what is noise figure. I'll try to teach all the terms that you have heard or maybe listened today in the expertise talks, SNR, noise figure, phase noise. Every term I'll try to cover as much as possible, and following with the one LNA design in the tool, and I'll also share some topologies so that you can experiment them on for your own, for your for future. You can use those topologies for your for if you want to study more about LNA. Okay, on the last day of this workshop, we will try to simulate a 5G system that will be using other software, CPP SIM. We'll try to give a total link budget, that how our link budget is set up with the components, with 5G components, and we'll try to give you insight of the 5G system, how things works there. Okay, so I think that's all from today. I'll always like to end with a good or a motivational thought. So for today's, it is like we are all given the same 24 hours in each day. So it is all depends on us, how we spend our time. That will determine our success, and it will also determine how our happiness. So that's all from this session. I would like to take questions if one has. Okay, thank you so much, Kusuma. I will try to give you as much as possible information regarding matching network. Okay, digital RF. RF is basically understand what is RF. RF is basically radio frequency. If any digital circuit that you are making, maybe ADC or anything, that can work at a RF frequency. You always have heard of ADC now can work up to 1 gigahertz. So it is basically RF, digital RF circuit. Okay, but when you are talking power amplifier, okay, so power amplifier is when you are using as a power amplifier. It is not digital power amplifier. It is not when you are transmitting, when before antenna there is a power amplifier that boosts the signal so that antenna can transmit it to some place at which you want it to be delivered. So for that you need to, I would say, to boost the power, you need to boost that power. So for that you need power amplifier. So that power amplifier will be analog design. So digital RF or analog RF, the difference you are asking, it is not like that. It is basically RF, the circuit you have designed, whether it's a digital circuit design or an analog circuit design, whether it can work in a RF frequency domain. That is what it is defined as digital RF or analog RF. Biasing network, I will try. I will topologies that will be used for biasing of a LNA, and that is a very good question, Soham. I will say power amplifier. There comes I will say a linear power amplifier. If we want to use a wireless communication system, in that we want a power amplifier to be very highly linear. But there is a trade-off. I already told you, as an analog designer, there is nothing like you can increase one thing and other thing will also increase. So it is not like that. So in communication system, you need a very highly linear power amplifier, but it comes at a cost of efficiency. So if you want to pursue a PhD, I will say it will be a never-ending topic, the trade-off between the efficiency and the linearity. There are many topologies available in the research papers. You can search IEEE. You can search for the terms I can quote you to the Doherty amplifier, load modulated balanced power amplifier. Each research that is going, it is right now taking in power amplifier domain is because of this trade-off. That is the linearity and the efficiency. If you want your power amplifier to be linear, it always loses efficiency. So there are techniques so that you can have a good efficiency at some power, some linearity level. But obviously for that you need some sort of specification. You cannot say that I will achieve that much linearity and I will also achieve efficiency. You always have to be in some specification. Okay. I have a little experience in RF simulation using is there any ADS is like you can design anything in ADS. It is a paid software. And I will say if you have experience in ADS, you will learn things more. Okay. So with this tool, then Python, you will learn how the things working in ADS. In ADS, it is basically GUI. Now here you will learn how those things were working in ADS. ADS is basically, I will say, the best tool for RF design. Basically, best PDA tool for RF design. Digital PA is nothing like digital PA. No, because you have to. I will say you have to transmit a carrier signal. That will be another carrier signal. That is not a digital signal. So there is nothing term called digital PA in RF domain or in basically in digital PA does not mean anything. Okay, so with good digital PA, maybe you can ask it in a better way by digital PA what exactly digital you mean. But in ADS also, in I am not able to get your question, Kusuma. Okay, I got your question. Using default inductor, your digital no class E and class F amplifiers. You can say they are not exactly digital. The basically in that domain, what digital means is class E. You can say class E are basically digital amplifier that cannot be used for communication. Class F amplifier, yes, they are used for the communication systems, but that is very narrow band. It will be like it will lose linearity a lot because they are very highly efficient amplifiers. This tool is basically open source tool. It is not technology dependent. You cannot include, I will say, any PDK right now in this tool. So it is not technology dependent. It is basically, it will help you if you are learning microwave and you are learning some designs. So it will help, it will assist you to prove your theory rather, I would say, and to help you in like lesser your calculations and all, so that if you do not have any paid software, then also the plus point of this tool is that you can even visualize your 5G systems with it. Okay, so it is basically Python. Okay, you can do anything with your things. So it will help you to give you a better understanding. But yes, if I would say you want to design a good system, obviously you will be needing a good EDA tool because in RF domain, what is basically done is we need electromagnetic simulation, and that electromagnetic simulation requires a lot of memory and a lot of coding as well. So we are actually doing it in we are trying to implement those techniques in this tool also, so that we can able to do EM simulation, but obviously it will require time, and it cannot be covered in this workshop because this is a very less time workshop. It is only 10 days, and if we pump all the information just now, it will be like a mess for you guys. So we want to give you an idea that how the things design. Okay, then if you want it further, then you can always connect with Gaurav sir, and we can have a specific design workshop designed for you guys. Okay, so if any institute want any specific design tutorial, or if they have any EDA tool licenses with them, or maybe we can arrange for them, so that is can be designed. But for this work, basically to give, because we have a wide variety of participants here. So we'll try to to give benefits to all. Okay, so we'll start from the basic and give will use tools to give you insight what is like how the things are working. Better PA, yes, you can implement PA, but what is the technology you will be using? That I will discuss. Maybe I'll use gallium nitride technology, not CMOS. So that I'll share those information when we will designing power amplifier. So we cannot use ADS right now, so I cannot do that for you, Hemant. That we cannot explain in this workshop. But yes, I can explain, but cannot explain in this workshop. I can say this like this. Okay. Because in this workshop we cannot use a paid tool. We have to use open source tools. So I think designing the question you have asked seems to be pretty simple, but it is a course in itself. Like you are asking me explaining about switching PA and designing PA in ADS. I am like I can give those training for like 1 month, and then you will be able to understand like what is exactly the issues are and all. But we will try to give you as much as information possible in this course. Okay. We will replace some component with transmission while designing filter and matching network, but transmission line have periodic nature. Yes, true, Soham, true. That will work, but what happens is with band pass filter or those filters, what we require is the attenuation at some particular frequencies. Okay, so it will obviously it will repeat, but yes, but it will have a less variation if you are using a lump component, because in lump component you will be having SRS and everything like that. You will face those issues at a very high frequency. But with the distributed, basically the transmission lines, you will not face those issues. So it will be always be better if you use transmission line for higher frequencies. And obviously periodic it will become, but if you are designing a filter at, let's say, 5 gigahertz, so it will repeat itself maybe after 12 gigahertz. So you need attenuation in that band only. So it will be a multiple band filter, but our design, again I will say, here comes the specification. Okay, so the things that you have mentioned is the problem. Okay, so it will repeat, but whether it is satisfying our specification or not, that we have to see. Okay, so in specification, if it is asking that it should not it have this much, it has the stop band of this much up to this frequency. So maybe, okay, so I'll quote example like this. Okay, so I think you have made a very good question here. Suppose somebody is specifying you a specification of a filter. Okay, so when you are okay, you know that the things will repeat when you design for a transmission line, and the frequency at which he is asking is like, maybe it at sub 6 gigahertz. So for that you will be designing it using transmission line. So he is not mentioning anything about at up to which frequency he needs attenuation. Okay, so but you know that transmission line, with transmission line the things will reappear. Okay, it will be periodic in nature. So at some frequency, if it is pass band, then after some frequency it will again become pass band. After stop band, it will again become pass band. So you will ask him whether if it is a pass band at this frequency, whether it will be acceptable to him or not. If it is not acceptable, then you have to tweak your design so that it will become periodic, but after that frequency. Okay, so that's how the design goes. So that is basically all about what I was talking about, the trade-offs. Because, or maybe if we say that no, I want attenuation at that frequency also, then you will say that okay, I will not able to achieve that much insertion loss in our passband as because you are asking attenuation at that frequency also. So that thing, that trade-off, you also as a designer also have to ask from your vendor, or maybe if you are working in a company, from your boss, because specification comes to you if you are a component designer from the upper level. Okay, so what actually thing that is going to happen is, suppose you have to transmit a signal from one place to other place. Okay, so that is the main task that has to be done. For that will come many from many fields, communication, signal processing, everywhere some people will come. It will so they all will sit to come together, and they will say that I'll be needing this much power to transmit. The channel modeling guy will say, okay, this much distance it has to travel. There the temperature is like this, so that I will be needing this much power. And my okay, so the receiver side, the designer of receiver will say, okay, my sensitivity will be this, so power level that will be transmitted should be like this. So that's how the things works. Okay, so to you the specification comes with like a more, I will say, with after the brainstorming at the upper level, it will come down to you with some specifications. So as a designer, you have to ask, okay, which can be like I can tweak, or all are the rigid ones. You cannot, like, for some design it might be possible. He'll say you the size is limited. You have to be restricted to this size. But if you design it using transmission line, it might be a big one. So you will ask him, if you want it to be in this size, I can. I have to. You have to relax me on this specification. So that's how this design process goes. So it is not a one day job. Okay, so if you are designing anything, it will take time because you have to see many aspects. Okay, so we'll try to give you that how to look, how to. I will try to give you. I will try to develop in you guys that hobby, or rather maybe I will that adat, maybe so that you always, if you get any design, you always go, you will always have that feeling that yes, I have to ask this, and that yes, this way we have to go. So that feeling you have to develop. That is the main task, because anything, you cannot learn anything like you cannot be perfect in anything. I am designing RF circuits from past 6 years. Okay, I have designed power amplifier, switch PAs, wideband PA from 2 gigahertz to 20 gigahertz PA, linear PA, Doherty PA, LNA, switch, phase shifters, everything I have designed, but still I am learning. Okay, so you cannot be pro in 10 days. But what I want that after this workshop, you develop that feeling that yes, I am a designer, and if I know this thing, then I can do this design. Or maybe I have a specification, I know some sort of theory, but with that theory I'm not able to meet this specification. So I have to update myself. I have to do a research. I have to go look for the research papers, to look for new topology, so that this new specification can be achieved. Okay, so that is basically RF design is all about. So I think with this I will end this. Otherwise, you guys will say it will be a long session for you guys today. So we will continue tomorrow. Okay. For 5G design, transmission lines are obviously, the last question I am taking of Gaurav Bhargava. For 5G design, lumped element circuit or transmission line circuit is chosen. Again, Gaurav, I will say it is not like that, that you cannot design with lumped element circuit in higher frequency. There are ways to do it, But again, transmission line circuit is always preferable because it has a less variation. But it does not mean that you cannot use lumped element circuit, because with lumped element circuit, you can achieve better performance, considering it does not have that parasitic effect and it has less variation. So for that, you need a good technology that can print or rather fabricate a good lumped element circuit that have a very much less variation and a very high SRF value. Okay, so I think that pretty much gives the answer to your question. Okay, so we will start tomorrow morning. I think 10 a.m. is the time. So I will hand over now to Firoza so that she can conclude for the today. And if she wants to give any information, so she can pass on. So that's all from my side, Firoza. You can take over.
Thank you, sir. Thank you for the wonderful session. So we'll again start tomorrow. So dear participants, so please note that the tomorrow session will start from 10 a.m. as per the schedule. And also tomorrow we'll be having our first MCQ. So that is from 2:30. We'll be having our MCQ. So from 2:30 to 2:45. So we request you all to please be present. The MCQ link will be present in the drive, and the drive link has been shared with all the participants through your registered email ID. So we request you to please keep checking your drive link for all the course materials. Even day-wise, the course materials will be uploaded in the drive, and the information related to quiz will be in the quiz folder. So please keep checking that, and your materials will also be uploaded in daily basis. So thank you, and thank you, Ashish sir, for the wonderful session.
Okay, thank you. Thank you all. Okay, we'll meet tomorrow. Good day.
Yeah, have a good day. Good day, sir. So we are also thankful to all the academy level coordinators and the proctor coordinators for being connected with us. And thank you.